It's always so annoying to remember. Okay, there's the YouTube stream. Okay. And I'm writing on a tablet now, and I've been getting used to it. It's a lot nicer than using a mouse, but it is a skill you have to learn. Yeah, I am. Hey, twist memes. Uh, so I was working on problem 7. Ignore 3.8. It's in the screenshot there because I needed the figure on the right side. Can even just X that thing out. And 3.7, like, I was working on it last night, and it just feels like a trick question to me. Like, it seems to be asking if you have a parabola that's facing downwards and you go down some given distance L from the vertex, can you go that same distance L to the left and be on the parabola still? And I feel like that feels like it should be a circle if that's true, but that's maybe off. Like, maybe there is a point such that this is true. But every time I think I have the equation set up properly, I just kind of get garbage answers. So my thought was I found the equations for the positions for like the x coordinate and the y coordinate, and this point right here is L comma L, and it happens at the time such that it reaches the vertex. Prismatic Queen, thank you for the follow. It happens at the time that gives you the vertex of the parabola, which is v naught sine theta over g. But when I actually like go through and plug things in, it doesn't really give me an answer that makes sense. Because I'll do v naught sine squared theta over 2g is equal to v naught squared sine theta cosine theta over g. And we want to figure out some relation between v naught and theta. Did I say sigma before? I mean to say theta, that's what I said, but the issue is that the v naught squared is just kind of go away entirely. And there's also no dependence on L, which is even weirder. Maybe that's not so weird. But even if we did solve this for theta, I think you end up with like theta equals 0 and theta equals pi over 2, neither of which are very helpful answers, because you're either throwing it straight up in the air or you're throwing it horizontally. I might just peep the answer, because I haven't made any progress on trying to figure out how to do this question, even after sleeping on it. So maybe we will take a look at the answer, or at least like the first few lines of the answer. What problem is this? 3.7. Wait, is t is an unknown? Apparent. What? I guess I'm misunderstanding the question. It is thrown. T is no. What? I don't get it. Let's look at more of the answer, I guess. They say so it's hitting horizontally, and that to me implies that it's the vertex of the parabola. Okay, yes. So, okay, we figure out. Okay, good. I understood that part. Yes. Now, how does this make sense? Dividing the second by the first. What? Is there not supposed to be dependence on V naught or L? Those seem like important things. Maybe related things. Oh, really? Twist means? Yeah, it's even I have a hard time deciphering the language that the book uses sometimes. I'm glad the concepts align well, though. You know, it's not written in language that's best suited for you. I make good progress on reading their. I flipped the fraction. On chapter, I'm nearly through with chapter 7 about induction. Every chapter I've read, I feel very lost, but when it comes time to actually, wait, what am I doing? Wait, I do want the sine squared one on top. Ugh. Yeah, with every chapter I read, I feel very lost once I'm done with once I'm done with the reading. But once I actually get into problems, I found that I actually am able to do things, which is good. So we get 1/2 tan theta equals 1. Theta equals arctan 2. So I guess my mistake was I was setting those two things equal to each other because they're both equal to L, but you're supposed to divide them. I don't know how you're supposed to, like, I don't know. Oh, okay. I'm surprised they don't discuss why it doesn't depend on V naught or L. Okay. Is it like a book for competitive exams, or is it just it's just for reading? It does contain questions, and there are challenge questions if you want to go that route. It's like at the end of each chapter, there's problems and exercises. And these stars are difficulty ratings. 1 star is the easiest, 4 stars is the hardest. And the 4-star ones, I haven't even tried because I'm struggling enough with 2-star problems, but like 6.7 is a 4-star problem about vector potential for a spinning sphere. And I don't feel nearly comfortable with basically maybe for like chapter 1 or 2, I could bite off a 4-star problem, but anything after that, and I don't feel nearly comfortable enough to even try a 4-star out of this book. The problems are very challenging, but it's not. I'm not interested in anything competition. So they're challenging, but they all have a kind of point in. You can get some type of understanding about, or that the problems aren't just doing physics for physics' sakes. They all have a point in helping you understand something about the chapter's content. A 1/2 √5 right triangle. Oh yeah, okay, I can see that. Really? Wow. I didn't think we would do this. So I thought that was the end of the problem once we found that theta. But if what they're saying is that tan theta equals 2 implies that sine theta is equal to 2/5. And you can plug it in. This equation is probably more convenient to find out what the relationship between V and L is. So let's even though we saw it in the solution key, let's work it out for ourselves. V naught squared times 4/5/2g is equal to L. Now let's isolate V naught. So the 2 in the denominator, we're going to divide out a 4. The 5 stays up top. So we get 5gl/2. It's okay to me. Is that what the book said? 5gl/2. Good. All right, so on to 3.8. That one I would like. I've been grading myself on these problems, and I feel like I bet I get half credit, but I'm just marking this wrong. Hey, syntax. How's it going? That is a large and in charge screenshot. It's a bit more reasonable. Projectile and tube. A projectile is fired horizontally at speed v naught from the top of a cliff of height h. Immediately enters a fixed tube with length x as shown in figure 3.10. There's friction between the projectile and the tube. Okay, so the only thing this tube is really doing is reducing our like starting velocity for the projectile motion part of the problem, it seems. What is the total horizontal distance, call it L, of the projectile that the projectile travels? Measure from the base of the cliff, give variance in terms of x, h, v naught. Oh, they use x as a distance. Oh, what am I supposed to use for the coordinate? Take the term using cofactor expansion. When taking the determinant using cofactor expansion, choosing the row doesn't matter. How come? Like, are you saying, um, are you saying if you have a matrix like this that, like, why are we allowed to choose any row to eliminate? Is that what you're asking? Oh, shoot, I'm not showing the right window. Sorry. So if we just have a matrix like this, like, are you asking why we can eliminate along any row to expand with? Uh, well, yeah, that's the term I always taught, but not everyone was taught. Like, basically, if you choose this row for your cofactor expansion, they become the coefficients for your minor matrices. So 3, whatever 2 by 2 you get, minus 0, whatever 2 by 2 you get, minus 2, whatever 2 by 2 you get. You mean that? Okay. So why does the choice of row, you can choose columns as well, to do that with. And why does that not matter? I don't know that offhand. Yeah, columns work equally as well. That's a good question. Why do they all lead to the same result? You obtain the same number by expanding cofactors along any row or column. Divided by 4, so to be clear. That's a proof for a different thing. Wait, is this the same thing? This is the same page. Yeah. Oh, maybe this proof is the one that we want. Okay, so they're starting by saying the cofactor expansion along the first column computes the determinant. And so they're starting by taking the... Where does this formula come from? They're just making this formula up, I guess. You've seen that should be equivalent. I wonder if there's a more intuitive explanation where So I don't. I try to read through and understand that proof, but I wonder if there's like another way that we could try and think about this. Hey, Nantham. When algebras are scary, they can be, yeah. Because we know that if we swap two rows, that just negates your determinant. So if you're willing to accept that cofactor expansion definitely works for the first row, let's say we wanted to expand along the second row, we could always swap row 1 and row 2, which will negate the determinant, but that's okay. 3, 0, 6, 2, minus 1, 5, 7. Oh, God. Uh, 7, 4, minus 3. And then to get rid of the negative sign that we're getting in front of the determinant, we can swap these two rows. And then you can do your normal cofactor expansion, and I imagine the minor matrices are going to come out to be very similar. Well, they should at least. Determinant of A equals... Hey, Sereno. You can use Saris. I don't know Saris. If you can prove the row things, the columns are free. Oh, right, yeah. Determinant the same under transpose. Sereno, the question from syntax is when doing cofactor expansion to find the determinant of a matrix, why are you allowed to do it along any row or any column, basically? Yeah, I think I remember that too, that the determinant is the same for the transposed matrix. Actually, yeah, syntax, have you learned about how row operations affect the determinant? So like if you take no? Oh, okay. If you have the determinant of this 3x3 matrix, you're in freestyling linear algebra, oh, no worries, is equal to the negative of the determinant of the matrix with any two of these rows swapped. So you could swap two rows, find the determinant of that if that's somehow easier, and then put a negative sign in front, and you get the determinant you want out. Why is, oh God, well, we have to look up another proof for why that is, but you can do any row operation before finding the determinant. So you can also add two rows together, and that doesn't affect it at all if you add two rows. So like 5, if I add the first two, if I take the first row and add the second row to it, that's completely equal. And then the other case is if you take a row and multiply it through by a scalar k, you increase the determinant by that same factor. And so you can manipulate a matrix to make it simpler before you actually take its determinant, and then just undo all these things that you just did. Always move it around. If you have a cube, as long as it's a cube, you can do whatever you want with it, rotate it, move it. That's probably... Yes, so, you know, it's like something like that. And I imagine the reason, or it's probably, the proof is probably something different, but it makes sense to me why we can eliminate along any row, or, you know, expand along any row or column. Found a video? Okay. See you later then. Henderson, since Syntax is watching that video anyway. A over B plus C plus B over A plus C. Positive values for A, B, and C that's set. Ooh. I'll take a look at that, Henderson. I'm warning you, if that's a competition question, there's like 99% chance that I don't know it. Hey, Stuki. Yeah, I definitely have heard of Saris's method. I don't remember how it works, though. So the question from Henderson over on YouTube is, we have this equation here, and we need to find positive why did I do that? A, B, and C that satisfy this equation. You don't even know if it's actually solvable? Okay. That's fair enough. I doubt I'll be your person, but the only thing that I can think to do is to get rid of these denominators. Yeah. But this is, I think you just have too many. Like, I imagine that there's infinitely many solutions for this because you just have three variables in one equation. Like, can you just make it easy and let like B and C both be one? Because they just have to be positive. Oh, whole values. Ugh. Honestly, I think you guess and check for this. Ren! You tell me I'm never going to use this stuff in life? Well, depends how you live your life, I guess. For most people, probably never. If we just let B and C be one, let's just see what happens to A. Hope you're doing well, Ren. So we'll play through by 2 and by a plus 1 squared, if I'm not mistaken. So I've seen Axler's measure theory. I know that you're just trolling, but the question of when are we ever going to use this in real life kind of like I feel like people pick on math in particular with that question, but if you're going to do that, you should at least be consistent and pick on English class and physics and chemistry and basically every other class that you take. And like, I guess I'm thinking of like the American education system, like the Air Force to be in until you're 18. If you pick on all of those, and I have no complaints. But if you pick on only math with that question, then I get mad. Not really that mad, but like, it's like, come on, man, just be consistent. Because I use hardly anything that I learned in high school in my daily life. And that doesn't mean it's not worth learning either. Your favorite question? Yeah. This is a cubic? That sucks. What's 1/2 minus 16 besides terrible? Negative 31 over 16? I think so. I didn't. Oh, I have to add 4. Ugh. Okay, back it up. Yes, Stugi just said hi. 1/2 plus 4 is 9 over 2. 9 over 2 minus 32 over 2 is minus 23 over 2? Minus 4? I think they left. That's true. I can confirm Suki is definitely not here right now. I doubt that doesn't look like it has rational roots. I don't want to plug it in and try. I bet the Wolfram Alpha might be able to just solve the A, B, and C equation. It might not find positive whole numbers, but let me just try the cubic that I found. 1/2 A cubed minus 7A squared minus 23 over 2A minus 4 minus 23 over 2A minus 4 equals 0. Oh, -1. What a tease. All right, what if I just give it the original problem? What does Wolfram Alpha find? B over A plus C. Because I don't know how you would do this one. Like, is the word analytically? This just seems like guess and check to me, and that's better done with a computer. Oh, that's a very convenient form there. It's simple. C is simply 1 over the cube root of 2, 3 to the 2/3. Is this like, what is this? This is all the value of C. That's even worse than the quartic formula. Or maybe it is the quartic formula, I don't know. Why would it be quartic? There's only cubes. I don't know. It looks too long to be the cubic formula. Dang. It must be the cubic formula. I don't know if I can really help you, Henderson. I'm sorry. I don't know. Wait, you know this problem, Stookie? It's a troll? Oh. What if I Google it? Quora? Quora's never failed me before. Quora is the source of all knowledge. It dethroned Wikipedia. This is too long. I'm not reading this. Oh my god. What the hell? Okay, well there's your A, B, and C apparently. I mean, it's still pretty troll to give this to someone and expect them to solve it, I think. No, here's a whole paper on it. All right, this is probably more instructive than anything I could do for you, Henderson. Looks like this is into depression stream. Yeah, it. My setup is pretty similar to his now, but it's just convenient things. Yeah, no worries, Henderson. I think it's the same core that I looked at. I'll pass it along to Henderson over the YouTube chat. I just kind of assume that that core isn't the best thing to cite, but eh. Oh, no worries. That's annoying. You got ads? So sometimes those pre-rolls are pretty Oh, you know what? I've actually definitely gotten mad at Twitch because I feel like when I first open a stream that normally just has the pre-roll ads, like it feels like they wait until I'm paying attention to actually play the pre-roll. Like I'll intentionally open people's streams a little bit early just to get the pre-roll over with, but I don't actually see it until I turn the volume up. It's like, is Twitch messing with me? Oh, it's not the right window. Remove that entirely. There we go. Okay. I hate that this problem already, like, it takes up X. Like, what am I supposed to use as my horizontal distance coordinate now? I guess we'll use S. That'll be Y. That'll be S. Change the plus with equal? For what, Sereno? For that, like, A plus B, C? The problem we're just looking at with, like, A over B plus C? So a problem like this, I feel like piecewise equations are probably the way to go here. So let's make a piecewise equation for A sub X. So at first, A sub X is going to have constant deceleration minus A. For T is less than something. Ooh, that's actually a little bit. Maybe we can't work out the time yet. Maybe we should look at the velocity at the same time. Because the first part of the velocity, it's going to be equal to V naught minus AT. And we want to figure out when it's traveled that distance X. So it's going to be V naught T minus 1/2 AT squared. And so we're going to take, I think, V naught T minus 1/2 AT squared and set it equal to X and solve this for T. Is that seriously a quadratic formula? There's got to be a better way. What is the horizontal? Wait, what are we actually? We're trying to get the total horizontal distance, call it L. In terms of X, H. Yeah, okay, so I think we have to do this. They're not asking like some simpler version of the question here. It's kind of annoying to quadratic formula, but I guess so. To minus V naught plus or minus V naught squared minus 2 times or 4 times 1/2 is 2 AX Yeah. Over A. I get anxiety thinking about all the parameters not taken into account in this physics problem. Like air resistance or what? Can we say anything about the discriminant here? Do we expect it to be... It definitely shouldn't be negative. Can we definitely say that it's positive or zero, though? So way to avoid the quadratic forms at the expense of solving one problem. Really? What would that be? When it's equal to x. I'm not comfortable saying the discriminant is definitely zero. We could just take this at face value, I think. Break up into two problems, going up and going down. Going up and going down. I mean, I guess the book has definitely used the technique of like thinking about reversing time and considering like the particles like going up from wherever it lands and like backwards. I just want to look at the book's version of the answer. I haven't usually found it more convenient personally, but this might be one where it would be helpful. Yeah, it's launching like the tube is horizontal and it goes horizontally into the tube. So this for the sake of the projectile motion part here, you could consider it just a horizontal launch with some other speed v1. And I guess the first thing I was trying to do is figure out like what v1 actually is, which is why I did the quadratic formula here. Maybe thinking about the vertical. Does thinking about the vertical help us at all? Because we did that distance h to think about. I feel like it's not going to be helpful. Maybe it is, because we do know L. Well, yeah, okay, maybe let's just think about the vertical as well. It's 0 for some values of t that we don't know yet, and then it's minus g for some other values of t that we don't know yet. Linear algebra gets too bothersome because there's just so much of it. I guess it's, well, yeah, for y it's always 0 for this upper one, whatever t that is. I think Zach and Penson are doing a linear algebra like Twitch class in the new year. I don't know if that'll be too late to help you. So you're actually, wait, are you self-studying linear algebra or are you in actual class? I can't remember. So with the velocity with respect to y for this piece, it may as well have 0 y velocity, right? So we just get minus gt. We catch a few days ago. Yeah, I just remember seeing it in Zach's little like rotating banner thing. Or I think I maybe heard him mention it verbally too. You already did the small portion of linear algebra was necessary, doing more for fun and for future. Okay, yeah, so then that class might be well timed for you then. Complex numbers Diff Eq. Oh, okay. Will their linear algebra be VS? Is that vectors? Or matrices? I don't know anything about how their class can be structured. You'd have to ask one of them, I think. Did it all in 2 days? Oh, right. Is the equation you wrote for the x direction? All of my x direction stuff is up here. I thought it might be helpful to think about the y's first to see if we can get something with h and l that might help for the horizontal that avoids that ugly quadratic formula that I'm not sure what to think of yet. Is that a smudge? Oh no, that's a part. Oh, dude, this what is this thing up here? It looks like a smudge. I thought it was on my monitor, but it's a part of the program. Why would that be there? Oh, it's a part of. Oh, it's a. Okay, never mind. That's me. Ignore me. I thought it was a part of the toolbar. It's like, why would you random smudge on the toolbar? But no. God, that's annoying. Can I scroll like a tiny bit? That's too much scroll. Can there's no like I can do okay there. Much better. Okay, I think the thing I was hoping for this was correlation between H and L that's potentially helpful. It might not be, but hey, Dr. Baum, do you have E&M study advice? I've been studying it myself. It's just kind of repetition. Like, it's kind of the same as anything else, I guess. Hey, Eric Song, can I solve on graph 2x plus 3 over x plus 1 equals p of x? What do you mean by solve? I can definitely graph that. But if you can tell me what you mean by solving it, that'd be helpful. One thing I can say, Dr. Baum, is I found there's a site where you can make some visualizations for E&M, which is helpful. It's called Falstat. Uh, and I'll drop the link to this in chat, but you can make visualizations for like electrostatics, magnetism, and you can simulate circuits, which is really helpful. Just okay, yeah, Eric, I can definitely graph that. And hey, class of 4, what is your background in math and other stuff? I am new here. So I have a bachelor's in applied math. The theme of the stream is I do math help, and when I have a question from chat that I'm able to work on, I do some kind of like self-studying thing. So I've been really interested in studying physics for the last maybe 9 months or so. Probably more like 6 months, but yeah, so what I was just doing above on the screen was some physics studying, but we're looking at this question from Eric Song about graphing p of x, which is 2x plus 3 over x plus 1. Okay. So whenever you have a rational function like this, usually the first thing that's helpful to look at is the denominator, because that gives you vertical asymptotes, because we're not allowed to divide by 0. And so anytime, so what we do, we take the denominator and set it equal to 0, and that's a vertical asymptote. So x plus 1 equals 0. It means x equals 1 is a vertical asymptote. And those are like jail bars, do not cross when you go to graph it. Hey, Divya. Another thing that can be helpful to graph it is to find the y-intercept, just because it's just an easy point to get usually. So like the y-intercept is when x equals 0. So we get 0 plus 3 over 0 plus 1 equals 3. So that's just a point that we can graph now. Now, the next part, I assume you might be a pre-calc student. This gets taught in different ways. I'm trying to figure out like what the best way to say this would be. Hey, Kira, welcome in. I wonder if there might be something more that we can think about. Okay, let's just draw the start of a graph here. One, two, three, 1, 2, 3, 1, 2, 3, 1, 2, 3. So x equals 1. We said that's our vertical oh, I'm sorry, that's x equals -1. Because we subtracted 1 to the other side. And then we also know our y-intercept 0, 3. Oh yeah, and Zachary makes a good point too that you can also find the x-intercept without too much trouble. By taking this thing equal to 0 And the way that with a fraction that you get 0 is you only care about the numerator, because if the numerator is 0, you don't care what the denominator is. As long as you have 0 on top, you're okay. As long as you don't also have 0 on the bottom at the same time. But here we don't get, so like if we got -1, that would be an issue. But here we don't. So we know that x equals -3/2. Oh, that's not 2. X equals -3/2 is another point, and y equals 0. So when x is -3/2, which is right here, y equals 0. Where's the last one? Y equals 2. Yeah, Zachary, that's the exact thing I was trying to figure out how to explain. So Eric, if this isn't familiar to you, I would maybe, this is taught in a few different ways, which is why I'm hesitating. So I'm trying to figure out what the most like general way is, or what the way is like that's safest to explain it. But if you have a fraction like this, 2x plus 3 over x plus 1, the degree on top is 1. And the degree is the highest power of x that you have. The degree on the bottom is also 1. And that's important because if you have, because it kind of governs how this thing behaves for large values of x. So like if you had an x squared up here, for large values of x, the top matters a whole lot more than the bottom. And for the same thing, if you had a squared on the bottom, then the bottom would matter a lot more for large values of x, and that changes how things behave. But when there's equal degrees, the rule is that for large values of x, we're going to approach the leading coefficients, and there's like an invisible 1 in front of that x on the bottom. So for large values of x, 2x plus 3 over x plus 1, we would say like approaches 2 over 1, which is just 2. So these are often called a horizontal asymptote. These aren't really as strict as vertical asymptotes, though, so it actually is possible to cross over these. Usually you don't, but it depends on the function. Akira, you can post a question in math homework help or math discussion. I'll take a look at that once we're through this question. Yeah, Zachary, I was thought in like a little bit of a weird way where like they were dancing around them without ever actually writing the word limit. It was kind of weird, which is why I'm trying not to use it myself. And so I'm also thinking in general, when we have like a rational function, they often end up looking something like this, or they might look like that. And so if I were to graph this rational function here, I think a very good guess is this, because I kind of expect them to stay in their little like quadrant with these asymptotes that we've drawn, and we know what one point in each of these is. Oh god, that's not a very good curve there, but and so this is probably as much work as I would do to graph this thing. If you want to be sure though, I would just plug in some more values of x and see and get some more like test points. So like I would plug in maybe -2 and -3 and then like 1 and 2 or something like that for x if you just want some more like test points there. But I'm like 99% sure the graph is just this. So I kind of think that's enough. And just to be sure, we can even plug it into Desmos too, rather than doing that. But yeah, there's some other tricks that you can do if you know some more advanced things, but I'm just trying to like keep it simple here, I guess. So yeah, it looks like I made a good guess here. So Eric, I hope that helps you. If you have any questions on what I did, please do let me know. But I think that's, if you're just learning this for the first time, that's probably how I would think about this problem. And it helps to just kind of know that graphs often end up having this, like, you know, one curve in the upper right, one curve in the lower left. Consider yourself with differential equations. Yeah, I've been build things. I know differential equations as like, as far as what you learn in like one semester of an undergraduate course. So depending on your level, I can help you. I see Akira posted a related rates question. So once I hear anything from Eric Song on that question, I'm going to move on to this one. Okay. Okay, so I haven't built things. If you want, you can type your question right there in chat, or you can put it in my Discord, whatever's easiest for you. Oh, Shane, welcome in, dude. How's it going? We rated Shane, I think on Thursday or something, but if you're interested in history, which I definitely am, like, it's like a hobby, I guess, or like a side interest for me is history, which is why I like watching Shane stream. I also like it. Go check him out. Melina says, hi, need help with the differential equation? Feel free to post it. Toonie. Oh, you're doing a line integral? Is that with complex variables, Toonie? E to the z over z squared plus 1 receives a positively oriented circular radius 2. I might be able to figure, if it's complex variables there, Toonie, I haven't learned that. If it's just a normal line integral, I might be able to struggle my way through it. But I'm working on this problem first from Akira. That's on screen. Doing mediocre? Oh no, had a day off work, so I'm mostly waiting for a plumber to come out and effect repairs on. Oh no! That sucks. I'm doing well. I'm definitely not waiting around for a plumber who's like not going to show up, or probably not going to show up. Thanks for asking. I just got this like a tablet to like write with, and it's been weird to get used to it, but I'm slowly getting there. Yeah. Akira, yeah, I have a bachelor's in applied math. So yeah, I'm sorry, Toonie. Do I know abstract algebra? I do not either. I'm sorry. Okay, let's try and read this related rates one. A streetlight is at the top of a 15-foot pole. A woman 6 feet tall walks toward the pole at the speed of 8 feet per second along a straight path. How fast is the shadow lengthening when she is 40 feet from the base of the pole? Ugh. Okay. How mathematically mature am I? As a person, I feel like I'm pretty immature, but mathematically mature, I guess I'm still pretty mathematically immature too. I have the handful of things that I know how to help with, and the rest I'm pretty shaky on. Definitely draw a triangle for this one. Okay, so that's a 15-foot tall pole. We have a 6. Let's ignore the units. We don't want units here. 6-foot tall woman there. She's walking toward the pole. At a speed of 8 feet per second. This distance here is 40. This distance here is the shadow. Doing physics, that's more impressive than line integrals. It involves a lot of line integrals. This is a pretty common question that I'd seen like a calc class, Zachary, but it's kind of physics-y, I guess. How fast is the shadow lengthening when she is 40 feet from the base of the pole? How do we do this? We do have similar triangles, I guess. Yeah, this is a related rates problem. That's even what that's what Akira titled as well. Oh, Ivan, I see you put something about a second order PDE. I'm not gonna know how to do that. Someone else might pop into the thread there and answer it, but I hardly know PDEs. Just don't want to waste your time there. And so the shadow is a lengthening. So what do we know about this? We know that from similar triangles, 6/15, that side and that side are corresponding, should be equal to this short side over the entire thing. So we'll call the shadow S. Why are you like that, cursor? So is equal to S over 40 plus S. This isn't gonna... This isn't great, though. Oh, thank you, Derek. Do you have any tips for the math section of the SAT? Ooh, good luck with the SAT, Canyon. For my recollection, the SAT math, it was all trick questions. Like, the actual math involved wasn't that hard, but they just have weird tricks in the wording. So I just be really careful with how you read the questions and take the wording very literally. Like, read it like a lawyer, basically. I appreciate the kind words, Ivan. Thanks, Canyon. And sorry, yeah, for anyone who's new here, I dual stream to YouTube and Twitch, so if you hear me talking to someone who's not there in the chat you're looking at, that's why. SAT, the math is involved a lot of computation. Yeah, as Derek says. Yeah, I'm not sure exactly how we want to use the... Like, we could definitely find what S is right now. But, like, S should be a function of something, right? Because we don't really have anything to take the derivative of here. Is something changing and I'm just missing? it. Because I do think, well, what did I score on the SAT? I remember taking it twice, and my scores, I think I got, the first time was a 1680, and the next time was an 1860. When I took it, it was out of 2400. There were 3 sections of 800 each. And I didn't care about the SAT, and I didn't study at all. I probably could have done a lot better if I actually did study. Yeah, no, it's weird to think about, but I graduated high school nearly 10 years ago. I think like next June, so. So the hypotenuse of this triangle is like moving inward. Is that the thing to remember here? The answer is always 42. Hell yeah. So the hypotenuse is shortening. So actually, maybe we want the Pythagorean theorem here. So maybe we can just... We have 2 Pythagorean theorems that are going on here. This is kind of a challenging relative rate swing. So I'm just not sure which, part of a triangle we want to use. So if we do Pythagorean theorem on the big triangle, what does that tell us? It tells us that 15 squared plus 40 plus s squared is equal to some length that we don't necessarily know. I'll call it c squared. And then doing a Pythagorean theorem on the small triangle tells us that s squared plus 6 squared is some other number squared. That maybe isn't the most helpful thing. When in doubt. Yeah, I'm trying to find the thing to take a derivative of, Rim. That's my problem. Oh, you know what? By similar triangles... Okay, so maybe I will label these then. This might be something. So that entire length is C. That smaller length is D. The similar triangles works just as well here, D over C. So D is also 6 over 15C. That seems like something, right? Maybe? I guess we should think intuitively in this situation. As the person gets closer, the angle is going to get like shallower and shallower. So I do expect this thing to be decreasing the length of the shadow. But trying to quantify that is a little bit difficult. Your equality is right, I think. 6 over 15 equals s over 40 plus s. Ooh, letting the 40 be a variable. Yeah, because that 40, it definitely is changing as she walks or runs or whatever she's doing. Why is she walking towards a light pole in the first place? So yeah, that's an interesting idea there, Derek. Let's try that out. So if we instead let that be length x, what happens here? 6 over 15 equals s over s plus x plus s. And so we could isolate s, I guess, and take the derivative with respect to x. So let's cross multiply this. My s's look like 5s, and that's not good. Equals 9s. Well, that's just a little bit too simple now, isn't it? Maybe that's okay. It should be linear, I guess. Because this is only like one dimensionally. Or it's only like one dimensional right now. Hey, hypergolic. I think we've set up an analogous equation there. Or like basically the same thing. So if we take the derivative with respect to each side with respect to t, we would get 2/3 dx dt. Oh yeah, good call, Derek. Because yeah, we know dx dt is -8. Oh, nice. Okay, that almost felt too simple, but it's hard to set that up and justify it. Okay, so I like this answer. Wait, when she's 40 feet from the base of the pole. Oh, you know what? I think what we found is it doesn't matter how far away she is from the base of the pole. It's just always reducing at -16/3. That's kind of funny. So Akira, let me back up and explain how we got here, because I was kind of fumbling through this for myself, so I didn't know what was important to explain or not. Yeah, Derek, you're right. It does match intuition. So what's happening is I drew all these triangles. Really, the important bit here is that the 40 they give us in the problem is going to vary. And so I just named that to be some other variable x. And like the shadow, I named to be s. And so using similar triangles with that small right triangle and the bigger right triangle, we can say that the two vertical sides divided by each other, 6/15, is equal to the length of the two horizontal sides divided by each other, because that's what it means to be similar. So the length of the short one is, oops, what did I just do? Is, please? Okay. The length of the short one is s, the length of the big one is our variable x plus s. So that's how I got to this equality here. So far over my head in this world is Shane. If it makes you feel any better, I'm getting a little bit lost in this problem too. Usually it's just me being confused because the people in chat are way better at math than I am. Oh, Zachary, thank you so much for working on that PD problem. Hope your migraine passes soon. Thanks for hanging out. LaTeX God right here, nice. So yeah, so we got to this equality via similar triangles. And now we all we want to do is just isolate s and get a function s in terms of x, and we find that s equals 2/3 x. So now I keep clicking something and it's messing with the cursor. Okay. Oh, is it that thing? I don't know. Anyway, we now take this equation and we take the derivative with respect to t, which is important because things are changing in terms of time. And that changes how these derivatives look. Like, people are really used to saying y equals 2/3 x and saying that y prime is 2/3. But that's not quite right here because this is a derivative with respect to x. What we're doing here is with respect to t. So x is changing with time. So when you take the derivative of it in time, you have to multiply by dx dt. That's a chain rule thing, or like implicit differentiation, if you've heard that term. Like that it's the same like why is that? Okay, that cursor is really annoying me. I'm not clicking anything. Forgotten Dreams, IDK, why I'm here. Fair enough. Thanks for being here anyway. What we find from this equation is that the rate of change of the shadow with respect to time is equal to 2/3 times the rate of change of x with respect to time. And so it's kind of funny, but the actual value of x, like that 40 feet we're given the problem, doesn't end up mattering for this part at least. So we know what dx dt is. She's walking towards the light pole at 8 feet per second. So that's like it's going down by 8. So we say that dx/dt is equal to -8. So all we end up doing is saying the rate the shadow is changing is 2/3 times -8, which is -16/3 feet per second. So that's for part A. I hope that made sense, but if not, please do let me know if you have a question about that part there. Looking at the second part, how fast is the tip of her shadow moving when she is 40 feet from the base of the pole? I feel like this should also be 8 feet. Maybe it's not. Maybe it's moving a little bit faster. Yeah, I guess it might be moving faster, because if she's moving at 8 feet per second, the shadow seems like it should be also. But the shadow is also getting shorter. So maybe it should be something a little bit more than 8. Hey, Fembucks. How's it going? Gotta think, why doesn't the 40 matter? It doesn't end up mattering. So it didn't end up mattering because the derivative that we found, it doesn't have an x anywhere inside it. And so that's why I said it didn't matter. It's not actually all that important for the problem. Like, just kind of take the equation you're given and plug in the values that you know. 15 streak. Wow, thank you. Just got home from work. Nice. Poppers 2, thank you for the follow. And I think it ends up not mattering because she's moving at a constant speed and something just canceled along the way there. If she was speeding up and slowing down, it will be more complicated. But when she's moving in a line at a constant speed, I think it just led to some simplification at some point. Key and Peele, yeah. I've got also the substitute teacher skit as a raid alert when he's like calling out everyone's names wrong. So close to one. Oh yeah, 993. And Chatter G Hive gave me probably like 20 keys for various games to give away when I get to 1K. So that'll be cool. I'll probably do it through the Discord and like give people like a week to enter or something. I'm thinking. There's like Civ 6. I don't remember what the other games were, but they're like for like 3 to 5 of each of the games. How fast is her shadow moving when she is 40 feet from the base of the pole? You know what? Is this actually... I feel like if... How should I say this? If she's moving to the left at 8 feet, then this point right here should also be moving to the left at 8 plus the rate that it's contracting at, which is 16/3. That feels almost too simple. But I think that's the answer. Hypergolic says sum up her speed and the speed of the rate. Okay, yeah, so it sounds like you have the same idea, Hypergolic. And Derek agrees too? Okay. I feel like it actually, and so things are decreasing, so let's make them negative. Like that. And so 24 plus 16 is 40? Huh. Not 1. 3. Jonathan C., if you had to explain how to set up any random equation, how would you do it? That's a very big question, Jonathan. I have an idea for how I can address that, though. Let me say, Akira, do you have any questions about how I got that second one, because this is kind of a weird one. I thought it was going to be harder than it is, and I feel like this is almost still too simple, but it's right, as far as I can figure. I'm going to clear some way to talk a little bit about what Jonathan is asking. Sounds good, Akira. Thank you for the question. So Jonathan is asking about how to translate, or how to set up a random equation. And so I assume you're talking about word problems here. And a word problem that I really like to show an example of how to translate from words to math is percent questions, because it's this way I was taught in 5th grade, and it stuck really well. I just really like this way of thinking about percent problems. So if I just make a random percent problem, like say 23 is what percent of 50? We can translate these words directly into math symbols. So 23 is 23, 50 is 50. Those are the easy ones. Is normally goes with an equal sign. And what normally goes with a variable. That's what we want to solve for. So they're asking what percent here. So I'm just going to name the variable p. And we're going to multiply p and 50. So these words translate directly to 23 equals p times 50, or 50p. Now we just want to solve for p, so we can divide each side by 50 to get 23 over 50 equals p. That should be 0.46, right? Yeah, it is. And so your answer would be 46%. And so you can do this with any kind of percent problem you want. So you could also say, what is 13% of 20? And do the exact same exercise. What is your variable? I'll name it x. Is your equal sign. 13% translated to number is 0.13. 20 is 20. And I guess we're kind of saying that of is multiplication. So then now the thing we want to solve for is just 0.13 times 20, which if I can do mental math is no. I can't do mental math evidently. This shouldn't be hard. 5 times 13 is 70. Is it 7? No, that's way too high. 0.7? I need to actually, I can't do mental math. 0.13 times 20. It's a number though. I should have chosen an easier number. 0.3 times 20. 2.6. That seems reasonable. Hypergolic, thank you for the follow. 5 times 10 plus 5 times 3. I know. Oh, it's 65. I didn't even do that part right. Yeah. But yeah, your answer would be 2.6. My inability to do mental math set aside. And so this kind of system, it's not as clean for other types of problems, but a lot of times the thing they're saying what is your variable and is an equal sign, and that can kind of help you piece together what equation they want for that problem. Mina Habib asks, can you help with series? Yeah, I'm a little bit rusty on series, but if you have a question, I can try and help you. Catching up with the Discord. So you can put it right there in chat, or if it's easier to do like a screenshot or something, you can put it in my Discord. So yeah, I hope that helps, Jonathan. It is a little bit of a general question that's hard to say this is what you can definitely do in every scenario, but I hope that helps you at least like think about word problems a little bit. Or I hope it makes word problems a little bit easier for you to think about. Because that's like, to this day, that's how I do. I might not write it out like that, but that's how, whenever I want to calculate a percent, I translate the problem into that phrasing, and then I translate it into math. So, Lauren Engo, where did you get this document? This program is called Journal++, but the J is an X. Free, open source. I haven't used it much. A little bit that I have been using it. It's been good. Okay. Hey, whirling clouds. I'm just waiting to see if we might get a question coming in from Nina. I think Post uses. I think so too. I'm not currently a student, Whirling Clouds. I have a bachelor's in applied math, and I'm planning to go to grad school, but right now I'm not currently a student. Okay, so Mina is saying, oh, this type of series question. Okay. For reason, I was thinking of like a calculus like power series, but this is just a normal, it's asking about a series. So you have the sum from k equals 1 to infinity, sine squared k pi over 2 over k minus, we're not done yet. You thought we were done. Cosine squared k pi over 2 over 3 to the k. Huh. You're studying applied math right now, Derek? Ooh, cool. No worries, Mina. It's hard to format stuff in YouTube chat. Hey, Lord. I'm in America, in California. Yes, Sereno. So I'm looking at their deadlines are in like it's more like December or January to go for fall of next year. And so, Mina, I assume this is converge or diverge. Doing the same thing. Oh, sweet, Serena. Is another k with the cosine squared? Oh, there is. Yeah, there's a k on the outside there. A sneaky one. Like right there. This is a no k outside. Oh, k is, you're saying k is your index. I see. There is no k outside. Or like, k goes from 1 to infinity, but that k isn't part of the series. Just converge or diverge. Okay. This is definitely a challenging one. Is there anything to gain from trying to use the Pythagorean identity here? Oh, Phobos, there you are. It seems like a nice program so far. I want to figure out. I don't remember you seeing this on your stream at all, but like it'd be cool to figure out how to write a plugin for this thing. I think there's some cool things you probably do with Twitch and a plugin here. Hope your day's going well, Phobos. So I definitely don't know offhand. Like I don't really have any intuition for this series, but we could just kind of mess around with it. Like the sine and cosine are always gonna. I mean, these are just alternating series, aren't they? I think I'm making this too complicated. They're always 0 or 1. The cosine squared and sine squared, are they not? Maybe this way is still helpful though. Oh, thank you for subbing, Whirling Clouds. Just finish up work and stacking wood. It's chilly. Ooh, fire tonight. That's awesome. It's not cold, but I'm still wearing a hoodie because we just had a heat wave, so I'm used to it being stupidly hot. um Yeah, if it was, I probably. So like, I am just realizing we could rewrite the sine squared and cosine squared as some form of -1 to the to the k. So like for k equals 1, sine squared of pi over 2 is +1. So I would guess the sine squared is the -1 to the k plus 1. Because it's always alternating between 0 and 1, sine squared and cosine squared of k pi over 2. And so the cosine. Oh wait, that's 0 and 1, not 1 and 1. This is like a reminds me of like a Fourier series. I don't think it's exactly that though, because we have the extra denominators and stuff like that. How can we write? I guess it'd be we want 1 plus -1 to some exponent over 2, I think is how you would do this, alternating between 0 and 1. So if we just have 1 to the k, let's guess and check. If k equals 1, we will get 1 plus -1 is 2 over 2, which is 1. And that matches with that. If we have k equals 2, sine of pi is 0, and 1 plus -1 squared. Wait, isn't this... Wait, what? I did something wrong. No, I did the first one wrong. If k equals 1, it's 0. So I think we want k plus 1. Because... yeah, I think that matches now. And then for cosine, I assume we're going to want just k. Because cosine squared of pi over 2 is 0. And when k equals 1, the thing I wrote just above it, we have 1 plus -1 is 0. So I think let's throw out the garbage housing with the Pythagorean theorem. At least, yeah, because we can just get rid of the trig function entirely here. K equals 1 to infinity of 1 plus -1 to the k plus 1 over 2 times 1 over k minus 1 plus -1 to the k over 2 times 1 over 3 to the k. This looks much nicer to deal with now. I think a good thing to do is going to be to distribute the 1 over k and the 1 over 3 to the k. So we can have 1 over 2k plus -1 to the k plus 1 over 2k minus 1 over 2 times 3 to the k minus -1 to the k over 2 times 3 to the k. You can also 5 logical statements that have to do with sequences and limits. If all of them is to... oh, geez. All right. I'll try that papa after this question. So these two on the right are geometric. they're going to converge. This is alternating and decreasing. But the one over the 2k is harmonic. And so I think if you take a divergent series, you can add and subtract as many convergent series as you want, but the thing is still going to diverge. Like if you have a divergent series minus a divergent series, then you're talking, you might get convergence. But I don't see a world where, like, everything, the last three terms are all finite, and how does something finite ever beat infinity in the first term? So I think from here, this is enough to tell you that since 1 over 2k diverges, the series given must also diverge. I think that's how I would answer this problem. Hey, Viv. How's it going? Definitely the tricky bit here is realizing that, hey, Cold Gold, how's it going for you? I think the tricky bit of this problem is realizing these relationships here. And I've just seen the format of 1 plus minus 1 to the power over 2 before, so that's how I thought of that. That wasn't like original. Gold. We're just looking at this series from Mina Habib over in the YouTube chat. We're asked if this thing converges or diverges, and I just concluded that it diverges. It's 3 a.m. here. Oh, geez. I'm doing good too, Viv. Thanks for asking. Derek Chen might have a more elegant way. Okay. Hope you fall asleep soon, Cold Gold. There's the text. Let me copy what Papadoria is putting down. And Mina, if you have any questions on what I did in that series, please do let me know. I'm just getting ready for the next question in the meantime. Confused? Okay. So you're just given these two things. Or you're confused on these two things in particular, at least. Before I start looking at this, let me look at what Derek Chen is saying. For k equals 2n, sine squared equals 0, cosine squared equals 1. Oh, splitting it up based on the even and odd powers? Or not powers, but indices. Yeah, that's a nice way of thinking about it too, Derek. It's a little bit, or it's a lot simpler than, or if you haven't seen the trick that I did at the start here, I think that way is a lot simpler to figure out. Random math trivia, there's a notion of a limit of a collection of abelian groups of a certain kind? Huh. I have no idea what that would be, Cold Gold. I believe it. alternating series test, I think everything makes more sense. Yeah, no, that first step is not obvious at all, Mina. The alternating series test, I would say comes into play for that series right there. There's a lot of alternation happening, but it only really comes up for that second one. All right, so let's start thinking about Papadoria's question here. I'm confused on what those two could mean. My professor had mentioned some of them could be properties like convergency, negation properties, etc. So you want to know what 1 and 2 mean here? Let's see if we can figure it out. I want a fresh page for this though. I also have to do with sequences limits. The goal is to make it understood what the formal definition of boundness meaning exists with limits. The lines of the binder paper are kind of messing with. That's really annoying. The text doesn't line up with the binder paper. Oh well. So there exists an epsilon greater than 0 for all n for a part of the natural numbers, not a part. Oh no. X sub n minus a less than or equal to epsilon. For epsilon greater than 0 exists n part of natural numbers. It's an n greater than n. Let me just write out number 1 with notation, I think. Those problems were written like, oh, like the backwards E? Okay. So let's translate it into that. There exists, not that epsilon, other epsilon. No, actually, wait, which epsilon do they normally use? They normally use that epsilon, right? It doesn't matter. There's an epsilon greater than 0 such that for all n in natural numbers, for all n greater than n, absolute value of x sub n minus a is less than or equal to epsilon. I might need to say like there exists an a somewhere in here too. I think I feel like we need to scooch it in here. Maybe not though. I guess an a can be in the real numbers. I forget if you need that though. The first thing Ian Suki says, the first thing I noticed that those are opposites up to a change of variables. Yeah, these do seem the exact same. The only difference is those two were saying that x sub n minus a, oh, sorry about that, is equal to s sub n. Number 1 should be less than, oh. Wait. Number 1 should be less than or equal to epsilon minus a sub n? Like that? Then I'm not sure what's happening here. Let's think about it. And the s sub n should be at s sub n minus a? Really? No worries. YouTube chat isn't the most conducive to typing math anyway, so like this is a weird statement now. There, I'm sure these are right. Let's translate number 2 to the logic symbols. Oh wait, for all epsilon greater than 0. Really? There exists in n in natural numbers. There exists in n greater than n. I'm just gonna delete this because I feel weird by it about it. This seems like divergence then, in number 2. YouTube put LaTeX in the chat. Yeah, I'm working on a way. I think it's possible to get LaTeX that people type in chat to show up in Journal++, and I want to figure that out. Hey, Sully, how do you get a 9 in GCSE maths? I don't know. I'm not in the UK. I never had to take it. I don't have much advice specific to the GCSE. I'm sorry. Just solve the problems in Overleaf. That's an option. There, for all epsilon greater than 0, there exists an n greater than n such that I'll make it like a command, Sereno. So like you'd have to like call the command and then type the LaTeX, but I think it's possible because Journal++ has a LaTeX. Like you can already, there's this button right here is to put LaTeX in. So all I would need to do is figure out a way to feed the Twitch input into the built-in LaTeX thing that Journal++ has. That is the hard part, but I have an idea of theoretically how it could work. So this second one, it seems like it's divergence. Yeah, a sub n is weird. I think a sub n is the, well, I guess it's the that's some very late term in the sequence. So like I think a is like the hypothetical limit of the sequence a sub n, and then a sub n is the actual term that's very late in that sequence. Hey, Lole, welcome in. A math test tomorrow? Oh, well, good luck. Now, what that does, I have no clue. I haven't worked that part out yet. Let's consider the following statements and revise that are already familiar to you. Please note some would be negations or definitions. So yeah, I mean, number 2 looks like the negation of like a normal epsilon n limit definition, more or less. Which is why I'm thinking it's divergence. I forgot that's absolute value. Actually, do you say it's absolute value? Oh, I have the wrong color pen. Yeah, you did say it's absolute value. The first one, like, Well, actually, wait. Yeah, what is the difference between, like, I was thinking that a sub n is some term of the sequence, but then what is x sub n if not a term of the sequence? That is weird. Lele, can you help me with some chaotic theory proofs? I don't know. I've never studied chaos theory. I'm sorry. Um, yeah, this question doesn't feel well formed. So please identify properties that are already like I would say that number one is not a familiar property to me. I don't know. It definitely does not feel familiar if that's what the question is. um, I have a bachelor's in applied math, Lily. Yeah, I was wondering if there is some like triangle inequality thing that you can maybe do with that, like you're saying, Sereno. If we add the a sub n, I don't know what a sub n is even supposed to be though. Like, what's the difference between a sub n and x sub n? Like, if we ignore that, we could. Uh, what does triangle inequality say again? No one tells Zach that I'm looking this up. And I don't just like have it memorized. Oh, I mean, it might be going the wrong way. If we have the right, oh no. How would this work? It is going the right way, I think, because we want it, the thing we have to be greater. And we know that a sub n is less than or equal to the absolute value of a sub n. So we could also safely, wait, no, we can't make that. No? Yeah, that looks right, Derek. I don't think we can use it though. I thought we could use this inequality goes the wrong way. I thought this would be the key. But we're breaking the chain of inequalities over here. Yeah, Papa, I don't know what to do with that first one. It seems like a trick question. So your classmates are probably a better resource than me here. Yeah, they just kind of start saying x sub n and a sub n and a. A sub n is sum of that constant integer a n times. Really? That would just be a times n. Why didn't you just write that? Okay. We're on the same page then, I guess. That doesn't... So if it's a times n, I still don't know what that gets us. I think a is a real number. That's how I'm interpreting a. It's just whatever your guess for the limit is. Wizbro, thank you for the follow. So I feel like we know what everything is here then. A times n is just a weird thing to have thrown in here. I'd never seen it before in this context. Isn't this blowing up your value of epsilon? Like, what the hell? I don't think this means anything. Or no, it's making it negative. Wait, if n is a very large value and epsilon is very small, are you getting that x of n, the absolute value of something is like less than or equal to like a negative number, and that's just not possible? That can't be valid. It seems like a trick. Like a times n is completely just, I think it's just wrong here. Because I think you can conceivably get negative numbers on the right hand side, and that means this is a useless thing to say, as far as I can tell. No two same thing, but instead of a n, it's a over n and a over n squared. Oh my god. Why? See, now those at least can conceivably also be convergence. I don't get why they're there. All you're doing is taking your epsilon, but like at least in a so like the bright side of a over n and a over n squared is that you're at least not making, you're probably not making your epsilon negative. So I think it's just a worse version of the definition of convergence, as far as I can tell. Like, it's just kind of stupid. But yeah, this is confusing for sure. Review of real analysis and introduction to complex analysis. Oh, okay. Yeah, I don't know what to tell you here, Papadoria, aside from this makes no sense. It's a cute emote Ren. Yeah, Papadoria. Thanks for trying, but I'm with you. It doesn't seem to mean anything at all. But I mean, two seems okay as a definition for divergence. I don't see an issue with it, but the rest of them are just weird. Yeah, no, number one just seems to contradict itself. So like 2 and or like 3 and 4 at least have a chance to not contradict themselves. Pranav Gupta, do I know hypothesis testing? Yeah, I mean, if it's like what you'd encounter in a normal like stats class, like a Z test, a T test, I know those. You can finally see the problem. Oh, nice, Ren. Craigasm indeed. Because I don't think we have anything, unless Pranav asks a stats question. I think we're out of questions from chat for the time being. So we can keep on thinking about this one. Say the basics of hypothesis testing. I could try and talk about it a little bit, Pranav. Mayor Estag, the 3n+1 question? What question was that? Did you put in chat earlier? If I missed it, I'm sorry. I don't remember seeing a question from you. And that may be my fault entirely. I'm scrolling up in the YouTube chat. I don't see anything from you. Oh, you're joking? Okay, okay. The plumber states that he will arrive in a series of times from 1 to 3. What is the percentage chance he does not show up until after 5 p.m.? 100% Shane. No calculations necessary. Yeah, no joking allowed here. Hey, Anders. All right, so Pranav wants to know about hypothesis testing, and Ren is giving us a good start here, which is you want to start by determining a null hypothesis and an alternative hypothesis. Oh, dang it, I nailed alternative and I flubbed it on hypothesis. Hypothesis. There we go. So an example is, say the null hypothesis is I guess we can do proportions. I don't know. Let's say like the proportion of people with brown eyes is 50%. I don't know. Ugh. So the null hypothesis is kind of like the existing claim that most people would think. And the alternative hypothesis is what you're saying it should be. And the trick with the alternative is it's always like the null, but you say it's greater than or less than, or not equal to. So your options here are greater than, less than, or not equal to 0.5. Let's say we want to test for like not equal to. It's 80%, Shane? Oh, wow. I'm a great message. My handwriting makes me look like a doctor. Sorry. Oh, you didn't spell determining right. It's hard to talk and write at the same time. That's my excuse. Determining. That doesn't look right either. I think it's right, but it doesn't look right. I forgot the P in the first hypothesis. Wait, no, I'm good on that. I can't talk and type at the same time. Yeah. So yeah, the null is kind of like what the status quo is. The alternative is what you're trying to prove. So all you can do is say not equal to, more than, or less than. You don't say it's equal to 0.6 or something else. Oh no, I made the same typo twice. Yeah, the P in hypothesis. Dude, who even am I? I'm not as math, I'm not done as English, okay? There we go, hypothesis. Since so for step 2 here, our alternative hypothesis is not equal to, we do a, oh, Ender. Oh, that alert isn't set up right. That cut off way too early. Thank you for the 100 bits though, Ender. I really appreciate that. When will Dawn do English? So hopefully never. So since our alternative hypothesis is not equal to, we're doing a two-tailed hypothesis test, and I'll explain what that means in a second. We do need to choose an alpha level as well. Yaroslav, can you help with calculus 2? Yes, I can. Yeah, so Pranav, that's something that I forgot to address. You wouldn't say P, you would say like the alpha value. And that's your cutoff for when you reject or fail to reject the null, as Derek says. And so we're basically, what the alpha value is saying is that if we go out and take a sample and look at people's eye colors, and we find that it's not equal to 0.5, what the chances are of that happening randomly. That's what we care. That's what we're trying to kind of, I guess, discredit. Like, we're trying to say this couldn't have happened randomly, and our cutoff for that is like a 5% chance. So if we find that we found 60% in our sample have brown eyes, and we do the math and we figure out there's only a 3% chance of that happening randomly if half of people have brown eyes, then we would say that's, you know, small enough of a chance that we'd say that the estimate of 50% of people is probably wrong. The phrasing for stats is very weird. And I'm trying to be careful with how I'm saying stuff. And so what a two-tailed hypothesis test is, we need to look at the bell curve now. In the middle of this thing is 0.5, our null. This is way more than the normal math, Jace. This is something you would learn in a stats class. Like, I learned this in high school, I think. Not everyone does stats, though. So, we draw this bell curve, and we say that we're in a two-tailed test. We're interested in either end of the curve, where each of these halves, the area is half of our alpha value. So that green area on the right is, oh God, that's not good. It's half of 0.5 is 0.00, no, 0.025. And we're also interested in the green area to the left that has the other half of the alpha value. By the way, Andrew Shelves, I hope you're doing well. And so So statistics is murder. I had to take an MA level stats class for your sociology degree. I never had stats before in undergrad. Oh no. You had to learn basic stats and the SOC stats. It was bad because of a lady in New Zealand put her whole stats course online. Well, thank God for that New Zealand lady. Stats is really difficult. It's half an English class. Dance Ninja, I can talk about that problem in a minute here. Currently pursuing data science as a career, and the stats is really interesting. Oh, cool, Pranav. And so how we're going to proceed is that we kind of assume that the null is true, and we're trying to find some crazy result that makes it seem like it's probably not true. So if we get, if we take a sample and we get a proportion that's way out in one of these green areas here, I think we call it like p hat. I'm just gonna make my number like, I don't know, like 0.7. I don't know exactly where the cutoff is. We would say that we're going to reject the null hypothesis. Whereas if we get something that's maybe a little bit higher or a little bit lower, but not enough to say it couldn't happen by random chance, then we don't have enough evidence to reject the null. It's like, say that's like 0.45 or something. Because just by random chance, you're not going to get exactly 0.5 every time. So you have to try and find something that's so out of whack that 0.5 probably isn't right. And so we can even think of it as like, if we get something in these green zones, we're going to reject the null hypothesis. And if we get something in the blue zone, it might be out of whack, but it's not far off enough for us to really say anything. So in that case, we fail to reject the null. And so actually calculating the p-value really depends on your situation. With proportions, there's a particular way that you do it. But if you're measuring something like people's height or their income, there's a different way. And depending on the information you know, it can change. So like there's the z-test, a t-test, a chi-square test, an f-test. There's a whole bunch of different tests that'll get you p-values in different ways, depending on your situation. But that's kind of fundamentally what's happening with hypothesis test. I should make the disclaimer. These p's up here are proportions, not p-values. That's an important bit that I should have stated. Machine learning math is so great. Yeah, that's something that I need to look into more. Let me take a quick break and look at Dance Ninja's question because it's a quicker one. So Dance Ninja, if you're still here, thank you for your patience. You have a line GH contains the points G minus 2, 6 and H 5 minus 3. What is its slope? Orlando, if Jerry has 4 apples and buys 2 more, how many apples does he have? 6. So Dance Ninja, you get slope by getting, I remember as slope is rise over run. And what that means is name one of your points as, say, x1 and y1, the other point as x2 and y2. It doesn't matter which one, just call one of them x1 and y1, call the other one x2 and y2. We usually call the slope m. We say it's going to be y2 minus y1 over x2 minus x1. So again, it doesn't matter which one is 2 and which one is 1, but be consistent about it. And we say rise over run because the y's are like the rise. Because y is the vertical axis here, and the y values control like how high up your line goes, whereas the x values control how flat it is. So that's like your run. So all it's left to do here is to actually plug in the numbers that were given. So y2 is -3, minus y1 is 6, x2 is 5, x1 is -2. So we can clean this up. -3 minus 6 is -9. 5 minus -2 is +7. And that's just our answer. -9 over 7 is our slope. Okay, so we have three people asking questions all at once here. Jaden chatted first. Xn plus yn equals zn, in which n is a natural. Isn't that that's that one guy, Fermat. No, yeah, I'm gonna assume that's a troll or something. I don't think you're asking about that Fermat. Xn plus y thin equals z to the n. Welcome in though, Jaden. So next was Yatharth is asking about synthetic division. Yeah, I can do synthetic division. I need to remember exactly how it works. It's a little bit weird for me. I do have a Discord as well to post questions if that's easier for people. So let me, because we got a few people happening all at once here. Let me just write out what's going to happen in one. So Yatharth is asking, oh yeah, and so Isabella, you can post it in the Discord there that I linked. Yatharth is asking to do 2x cubed plus 3x squared minus 4x plus 10 over x minus 3 via synthetic division. Isabella Lopez has a question to be posted. Cole Hewitt wants f of x equals x cubed plus 2x squared minus x plus 3 minima and maxima on minus 10, 10. And Yaroslav this is, yeah, I mean, YouTube has decided it likes my stream today. I don't get why it decides it sometimes likes me, usually hates me, but today is one of the good days, I guess. Okay, so this is the queue. I think as I know it right now, if I've missed anyone, please do speak up and tell me, because it wasn't intentional. Wave hi to people. I see. Okay, Isabella posted their question to the Discord. So I'll look at that once I get to it. All right. So we're going to start with Ytharth here about synthetic division. I think I remember how to do it offhand the more that I think about it. So we have 2x cubed plus 3x squared minus 4x plus 10 over x minus 3. How we set up synthetic division is we take this term on the bottom, and I believe we put it up here in the corner. So we have x minus 3, so we take the 3 and we flip its sign. So the minus 3 becomes positive. And then what goes to the right here are all the coefficients on top. So 2, 3, minus 4, 10. Actually, I do need to look up this next part, because I don't remember exactly how you do the next part. Synthetic division. Synthetic division is super convenient. Like, it's a really quick way to do it, but it involves a lot of memorization, and I don't like memorizing things. So yeah, you drop the numbers here down, multiply the carry down by the, okay, then you add down. Okay, cool. So what happens is we're going to start by taking this 2 and, oh wait, I'm already off to a bad start. Do you multiply it or you just carry it right down? You just carry it right down. Okay. So you take the first number, you just bring it right down. And now the procedure is you take the number that's on the bottom, multiply it by this number, and put it in the next spot, like up above. So we do 2 times 3 is 6. So we put the 6 there, and then we add down the line. So that's 9. Now we do 9 times 3 is 27. Put it there. Add down the line to get 23. Now we do 23 times 3 is 69. Nice. Add down the line, and we get 79. So those are the coefficients of what we get. We have to remember that we started with x cubed and we divided out one of our x's, so we should expect a quadratic for our answer. So we're going to get 2x squared plus 9x plus 23, and then this 79 is the remainder. So it should be plus 79 over x minus 3, whatever the denominator was. Let me verify that in Wolfram, but I think that's all there is to this problem. Just because I don't remember this perfectly. 2x cubed, 3x squared. Minus 4x plus 10. Over x minus 3. Uh, 2x squared plus 9x plus 23 plus 79. Okay, perfect. So yeah, Ytharth, Ytharth, I'm sorry. If you have any questions on that, please let me know. But since we have a couple of questions in queue here, I need to keep it moving. Yusef, implicit differentiation, I can, but you're going to be now 5th in line. X, is that x squared y? I assume it is. Plus y squared x equals -2. Find dy dx. Okay. Yes? Okay. Thank you for confirming. All right, so Isabella's problem is next. That was posted to Discord. You had to translate it, so ignore the background. Okay. Oh, that's a... Oh, let's scale it down a bit. I can add you to the queue, Jaden. All right, consider the linear systems. Oh, okay, so the translation is going to be a little bit rough here. Potentially, or select the correct alternative. There does not exist. Oh god, okay, let's actually, I regret making the image smaller. Let's make it bigger. Angle, oh gosh, all right. Jaden. Does not exist an M in R such that S1 is equivalent to S2. Oh, geez. Exactly one M greater than 0. Huh. So are they asking about row operations here? I don't know if you know matrices, Isabella, but I'm writing these out with an augmented matrix. It feels a little bit easier for me to look at, personally at least. If you don't, I'll explain it without them, though. What a weird system. You know them? Okay, cool. So I think what they're asking is, can we conceivably do row operations to make these two things match? That's how I'm interpreting kind of all of these statements. And that depends on the value of M that we have too, which makes things a little bit worse. I wonder, I mean, is there an easier way to do this than trying to reduce things? Like, I see that this one has 10, 0, 0 in the first column. And so I'm wondering if we want to take this first matrix and at least get the zeros in the bottom two ones there. Yeah, Derek, this is definitely an ugly problem. Like, I'm also looking at things like this bottom row has like 1 power of M on the left and 2 powers of M on the right. And there are no rows in the first one that match that. So that could mean that M must be 0 or 1. Actually, I think that's just a good idea. Because I don't think there's any row operations you can do to fix that. I'll be here for while doing some homework. Let me know. Okay, sounds good, Jaden. Just the one that's on the screen here, Anders. It's posted in the Discord too. Oh, for that one? I'm not solving for a specific one right now. I was trying to think about these in general. This is what I'm thinking right now. So like that would at least give us only 2 cases to look at. I don't know if this is right though. Like this feels right to me. And the only way the power wouldn't matter is if we have 0 or 1, is what I'm thinking. Yeah, Dr. Cook, it wasn't originally in English, I think. So they put it through a translator. So I'm thinking that if we can take the statement that I put on the right there and run, like m equals 0 and m equals 1 probably aren't that bad to check manually. Rouge Frobenius? I never heard of that. Rouge Frobenius. Oh. Is that his... I forgot it's the Rouge-Capelli theorem in English-speaking countries. That's weird. Why does it change? Either way. System of linear equations with n variable coefficients in a field K has a solution if and only if the coefficient matrix K they have the same rank. This is too advanced for me. Affine subspace. I need a simpler. What is it called in English? Rouge Capelli? I'm just not completely sold on the thing that I wrote. If you can tell me how to use Rouge Frobenius Sanders, I'm all ears, but I don't think I'm going to figure it out quickly. You row reduce the matrix so you can use its rank. Oh, so we still have to do like row reductions? Hey, Dyslexia. There's a bit of a queue right now. I can add you to it. I'm on the second one, though. Sorry about that. And Jack, I can do that, but you're getting added on as number 8 here. So right now I'm on number 2. Hey, Smiler. Dang it. Do we have to do row reductions here then? Since it's finite dimensional, you can instead calculate the nullity and compute the rank. You can, Ren. I feel like I probably can't answer a question from you though. Calculate see how many zero eigenvalues the matrix has, then compute the rank as rank equals. So why is the rank in, well, if they have the same rank, does that, like, how do we use that information? We get the lines without M and build another system. Get the lines without M and build another system. It can help you to find M. Really? So we do have 3 equations that don't involve M. Huh. Oh. I guess we could try that. Hey, Hardlocked, thank you. So, that seems reasonable, because if they are equivalent systems, couldn't we look at, we can just mix and match the equations that don't involve M, solve it for X, Y, and Z, and then plug those X, Y, and Z values into the ones that do involve M and see if they're all consistent? That seems like the best way to do this to me. Because trying to figure out the rank thing seems weird. People who do this exam know matrices, so you can use them freely. Okay. I guess let's try that. Please do Jaden's, sorry, Yakshir? I'm probably saying that wrong, but they're, I'll get to Jaden's when I get to Jaden's. 4x minus y equals 2. 12x minus 3y plus z equals 8. I forgot what the rest of it was. Plus z equals 8. Jaden has to leave in 15 minutes. Well, there's other people who have been waiting longer, so is Jaden in the Discord? I can get back to them after the stream or something, or I can just get back to them in Discord and they can look at it when they have time. Five z plus 4, 5z equals 14. Okay, yeah, Jaden, that works too. I'll type something in the YouTube chat, so when you're looking back through the video, it'll make it easier for you to find the spot. Yeah, sorry, when there's just a queue of questions, like there's only so much that I can do here. So I mean, this approach seems pretty reasonable to me. -3 plus 3 is 0. That's 1. That one stays the same. 8 minus 6 is 2. Swap 2, 0, minus 5, 5, 14, 0, 0, 1, 2. Yeah, Derek. M equals -3 is the only M that makes this an equivalent. Oh, okay. Thank you, Lubird. So Isabel, it sounds like there's a tentative solution that m equals -3 is the only solution, but not confirmed yet. Did you do a similar technique, Lubert, or are you doing something like what Anders and Cook are saying? I'm kind of shying away from that because it's more linear algebra than I know. Oh, this is just not consistent. Or no, there's simply, no, never mind. It might be consistent. No, this isn't consistent. You love Keanu Reeves in The Matrix? I mean, who doesn't? um, there's got to be a better way. Or like, is there just like a better, or I mean, maybe that is the way, and I just found that there isn't. But if Lubert did get a value of m equals -3, then I would have done something wrong, because I would say that there aren't any. Unless, well, no, that doesn't mean, just because it's inconsistent doesn't mean it's not, like, you can have two equivalent inconsistent systems. Right? Ugh. But then what do we know to, like, what do we plug in? We don't have homogeneous. Derek Chen, I'm sorry, also got m equals -3 as the only value. I mean, I was trying to avoid it, but like, there's the brute force way of just taking these two. Like, honestly, I'm at the point where I'll just take these two things and try to row reduce them. Squared -4, 1, -2, 0, -3 plus 3 is 0. That stays 1. That becomes 2. Can we safely multiply row 3 and the other one by 1 over m? That feels dangerous to me. Maybe it's not. We could instead do plus m times row 2. Donald, but I go by Dong. Uh, 14 m squared plus 14m minus 56. Long dong dong. The long dong dong. That's a tongue twister. I mean, this seems like something, I guess. You would have 14 equals 14m squared plus 14 plus minus. That should be a minus 56. Um, 14z. Room tour? No thanks. But from the first one, z should equal 2? Maybe? I feel like I'm playing with fire here. But 56 plus 28. 84? Divide everything through by 14. I should have divided through by 14 first. That would have been simpler. I'm here now, though. That is 6. So candidate values are -3 and +2. And we can throw out we have to try to confirm or deny these based off the, sorry, -3 or +2. Confirm or deny these based off, that's the answer, you just don't know how to get there. Okay. So how far did you get in the problem then, Isabella? Like, I'm sorry I wasn't really explaining it because I'm just like fumbling through this blindly. But all I've done so far is I just kind of row reduce these a little bit to get something that's easier to work with. From the second one, I was kind of like, sorry about looking at the z values, I guess. Like, the first one gives you z equals 2, and the second one gives you, like, that thing there, 14 times z equals that. And so I just combined both of those things because if they're going to be equivalent, they should both be true at the same time. And got that quadratic with m. And so, hey, Zach. I think we need to take our possible values for m, plug them back in, and see if we get something that makes sense or not. So agree with me, like, up until this point at least, but if not, let me know. In the world where m equals 2, because that answer should go away is what we're saying, I'm going to take the row reduced version of S1 and plug in m equals 2. You're up to it? Okay, good. So 2 squared minus 4 is 0. 1 minus 2. 0, 0, 1, 2. So that's inconsistent, but what if they're inconsistent in the same way? That's what I don't know. So let's look at what the other one looks like. 10, 0, 1. 4 plus 2 minus 1 is 7. 0 minus 5, 5, 14. Double entendre, math teacher, too many problems? Yeah. 0, 0, 14. Dude, okay. This thing needs to get multiplied through by 1 over 14. Oh God. I'm this is a terrible habit that I have. My teachers probably hated grading my work because I would do that all the time. So we have 4 plus 2 is 6, minus 14 is negative 8. 4 plus 2 minus 1 is 5. Oh, thank you, Cook. Derek, m equals 2, y, d, and e. Yeah, Derek, that seems to be the other way to possibly do this that people are talking about in Twitch chat, but I'm not that comfortable with matrices, so I don't. I kind of avoided it. Send the check in the mail. Oh, that's very generous of you, Cook. Thank you. I mean, we can just. Don't we just know that these two aren't the same from this stage? Because this one on the right seems pretty consistent to me. The one on the left does not. So I feel like just we can kind of eyeball it and say these two things, like m equals 2 does not work. It's like, I think we could get an x, y, and z value out of this augmented matrix on the right, and we definitely could not on the left. If m equals minus 3, what happens here, though? Nine minus 4 is 5. 1 minus 2. All right, see you, Jaden. Is the first matrix. The second matrix is 10, 0, 1, 9 plus 3 minus 1. 12 minus 1 is 11. It's all good, Jaden. Minus 3. Okay, so. Oh, wait. No. Not 11. 9 minus 3 minus 1 is 5. The second one, 9 minus 3 minus 4 is 2. This one we'd have to do. This one is one that we should be able to get. We should be able to make the match. We have to do raw operations to actually show that, though. Annoyingly. 0, 1/2, 0, 1, 1/5. Actually, Oh god. Since the queue is so long, I probably have spent too long on this one. I'll try and see if I can get this through quick, but I should probably look at the rest of the queue pretty soon here. But I think this is the idea, that you just row reduce these and show that they're equal. No, Isabel, it's completely fine. It's not your fault. It's just it's always just really hard to budget my time when there's a lot of people waiting. You've done nothing wrong. Yeah, it's not an easy question. Plus 1/4 row 2. But what I'm trying to, like, the idea here is that, like, if you're comfortable doing row operations, all I'm really doing from here is I'm taking the simplified matrix that I got for S1 and S2, and I'm plugging in these values for M, and I'm just trying to find either consistency or inconsistency. Oh, awesome, Dyslexia. Thanks so much to that person in the Discord. And thank you, Dyslexia, for letting me know. It's not it. So, maybe at this point, Isabella, all I would do in the problem here is, like, take these matrices for n equals -3 and row reduce them until they look the same. That's all there is left to do in the problem, I think. And we would have found there's only one solution for M. And it's a negative. So, like, it'd be C, I think. But is that, like, procedure? Like, does that at least, like, make sense? Would you be able to, like, carry this through on your own for showing why M equals 3 is like, why M equals 2 does not work, but M equals -3 probably should work? You think it's right if it works? I think it does. I mean, I guess I could use Wolfram Alpha to really... it'd take a look. Even putting in Wolfram Alpha kind of takes a while, but if you row reduce these, it's possible I made an arithmetic mistake, but they should row reduce to the exact same thing for M equals -3. So if I can, maybe I'll just hand the problem back to you and say, if you run into mistakes, either maybe come back in chat or, like, just post again in the Discord and say that you're having issues, and I'll try to solve it out properly when there's more time. Yeah, in the meantime, I want to start. So Cole a while ago asked a problem, and I should probably start setting up for that. This turned out to be garbage. Let me delete that. I guess I think it was. I didn't delete something important. Let me actually. I'm going to bring it back, so I don't remember what it was. Yeah, sure. Thank you for the follow. That 90 degrees when I've heard before. Okay. Oh, I should just use the scroll wheel here. Okay. I'm gonna maybe type Cole's name in chat, so in case they check the video, there'll be an easy way for them to find where to look. So we have this cubic, and we want to find the minima and maxima on -10 and 10. So I'm assuming they're a calculus student and they can take the derivative of this thing. So to take the derivative of this, we're going to use a power rule a bunch. We'll get 3x squared plus 4x minus 1. And if you want to find the minimum maxima, we have to set it equal to 0. Where the derivative equals 0 is where your critical points happen. We can factor this thing. There'll be a 3x, an x, a 1, a 1. We just need to figure out the signs. Wait. That doesn't factor, does it? Not cleanly. Quadratic formula? Yeah, wait, Yatharth, did you ask another question? I don't think so. I feel like I want to scroll up and see if we can find Cole's problem again. X squared, x cubed plus 2x squared minus x plus 3. No, okay, that's right. Yeah, Cole. Thank you for your patience. So I took the derivative, I set it equal to 0. It factored weirdly, so I thought there might have been I might have copied it down wrong, but it doesn't seem to. So I use the quadratic formula here. So Count Dracula, oh my god. Oh, you are Yakshir. I get it, okay. 16 plus 12 over 6? Yeah. Yeah, it's irrational. Okay, we can work with that though. Mateo, I can do that question, but there's a bit of a queue. So you're number 9, I'm currently on number 3. I need to try and get through these problems at a quicker pace, but I'm sorry about that. -4 plus 2 root 7 over 6. Awesome, Mateo. Thank you so much for your patience. If you have to leave, like, I'm just gonna type out everyone's names in chat when I look at their question. Just in case they have the stream on mute or something, or in case they go back through the VOD. Yeah, and Territar has the idea right there. You can't divide by 0, and you can't take the square root of a negative thing. But I'll explain more if needed later. Okay, so the minima and maxima on -10 and 10. So I assume they want us to actually like classify these. We have our minima or maxima here. And these are between -10 and 10 because root 7 is a little bit more than 2. Or no, it's a little bit more than, yeah, no, it's more than 2. Now there's sometimes like a little bit of a trick with these. You gave me parentheses here, but so I think we're okay. But a lot of times if they give you closed brackets, you do need to check the actual endpoints as well for what those values are. But I think with the open parentheses, we don't have that issue of checking the endpoints. They were closed? Okay, so let's do that then. Thank you for the correction. I can, what purpose of an inertial tensor? Hey, Ellie. I don't know. I never learned inertial tensors. I'm sorry. Maybe it's someone in chat who can speak on it, but I don't know them. So, actually, I guess the phrasing of the question here, Cole, it sometimes a trick question, but sometimes it's not. But if they want us to actually say what the minima and maxima are, awesome, Ellie. I appreciate that. So like they often ask for like a local min or max and a global min or max. And so things we need to check are x equals minus 10, x equals 10, x equals minus 2 plus root 7 over 3, and x equals minus 2 minus root 7 over 3. Okay, yeah. And so this is just, we have to plug the values in to the original cubic and see what they are. I'm going to use Wolfram Alpha because that's a little bit too much for me to do by hand right now, at least. Can I give it the cubic and tell it what x equals? Let's see if I can figure out how to do that. X cubed plus 2x squared minus x plus 3. And we want it to check x equals minus 10 first. Number line test? Oh, I mean, that works too, Derek, but I'm also trying to distinguish between global min and like local min. So that's why I want the actual values. Oh, what the heck? So f of minus 10, oops, is minus 787. Oh my gosh. Let's check f of 10. Is that going to be positive 787? It might not be. No, it's 1193. Now let's check the f of minus root 2 plus 7 over 3. Minus 2 plus root 7 over 3. That ugly number. Give me the decimal, please. 2.89, we'll call it. And then the other one is 5.63. Okay. Cool. So what we say from this information is that minus 10, 10, oops. You know, this is a little bit annoying. I didn't actually determine if they're minima or maxima with this work, did I? So, yeah, Dirk was saying to use the number line test, and I actually probably should have said to... I should have actually done that. Ugh, okay. Is there a simpler way? Yeah, I think there is. So I got a little bit of ahead of myself here, Cole, where... Oh, pen, hey! Once I found these as the coordinates of the local minima or maxima, what I should have done is figured out, use the sign test to determine if they are minima or maxima. And I'm just going to graph the parabola. I think that's the easiest way. Because we know it's a parabola facing up, and I don't really care what the actual values are, but when there's a plus sign in here, the thing is positive because root 7 is more than 2. So one of the roots is over here. When there's a negative sign, it's a negative minus a negative is a negative. So it's somewhere over here. There's your artwork happening. I'm sorry if you guys can hear it. And it's a parabola facing up, so we can fill in like that with the roots. So the root on the left, the derivative goes from positive to negative. So when the derivative goes from positive, let me actually write this out. Minus root 7 over 3. F prime x goes from positive to negative. So it is a, if it goes from increasing to decreasing, it's a maximum. And then at x equals minus 2 plus root 7 over 3, f prime x goes from negative to positive. So it is a minimum. And okay, and so all this was in the name of being able to say on the interval minus 10, 10, we have a global, what am I writing? A global maximum at x equals 10, or f of 10 is 1193. A local max at x equals minus 2 plus root 7 over 3. And f of that thing is 2.89. That doesn't make sense. I messed up my terms. It's the minus root. .63. And it is not every class is going to want to talk about a global min or max on an interval. So you might need to like filter this through how you're being taught it. But I was the way that I always taught you, like it's the global max on the interval, I guess. Oh shoot, this is a local min, what I'm writing. Yeah, Fenbox, I did. It's not Wacom brand, but it seemed pretty interchangeable with the Wacom one, and it was on sale, so. At x equals minus 10, and f of minus 10 is minus 787. Okay, so this is the answer that I would say, Cole. I hope this makes sense. I wasn't doing a very good job explaining because I was kind of going back and forth. And I might have done more work than necessary here too if they didn't ask for like this local versus global thing. But I'm just like trying to be careful with how they can trick you here. Yes? Okay, it sounds like this makes sense to you then. Are that our math skill? No, yeah. This is like, it's Huion? Huion? It seemed to do basically the same thing. I think it's a Wacom, but for like $10 cheaper. So no worries, Cole. Thank you for the question, and thank you for your patience. Okay, let's I need to free up some space here. Okay. another name off the list. We'll eventually get through it. All right, next up is Yaroslav. Can I type their name in the YouTube chat? This one, at least, is straightforward. I'm not going to waffle as much on this one. Famous last words. Yeah, YouTube decided it likes me today. So what we're going to do is we're going to take the derivative because that's the slope of the tangent. We use so the 100 stays the same because it's just a coefficient. E to any power derives to e to any power, but then chain rule, we have to multiply it by the derivative of the exponent. The derivative of minus 0.3x is minus 0.3. So let's multiply these all together. Minus 0.3 times 100 is minus 30? Question mark? Let's check that. $30. Okay, good. And so f prime, and so now they're asking at x equals 2. So we found the slope of the tangent at any point. They're asking for the slope of the tangent at x equals 2. So let's plug 2 in for x here. So I'd say the answer is minus 30 e to the minus 0.3 times 2 is 0.6. So I'd say that's the slope right there. And you also haven't seen you type in chat, so you probably have to go. I'm sorry about that, but I hope if you're checking the recording that helps you. Youtharth. Oh, Youtharth. You were asking me to shut you on. I was saying I don't remember you posting a question, but there you are. Let me at you in the YouTube chat. Youtharth. Oh no, you're not here anymore. Or at least am I misspelling it? Here's Yusef. Youtharth. Oh, Yatharth. Oh my gosh. Really? I misspelled your name? I'm sorry about that. Okay. Yatharth. For your implicit differentiation. X squared y plus y squared x equals minus 2, and we need to do implicit differentiation on this thing. So what we're going to do is we're going to take d by dx of each side. Okay. Yusef. Oh, shoot. I put the wrong person's name. Okay. Thank you for that, Derek. Yeah, I haven't seen them type in a minute, but in case they check the recording, I think it's easy. It'll be easier to find it if they see their name being added in the chat window. Ugh. So that's what I get for trying to multitask. So I kind of show this out in painful detail, but it helps me personally, so I'm going to show every step here. So when you have the derivative of something plus something, you can distribute that derivative. On the right side, we can just take the derivative of minus 2 as 0. And so now we have to figure out, we have two derivatives to take here. We have to remember that y is a function of x. So y is really just like, it's something with it. It's like hiding some x's inside of it. And that makes it weird when we want to take the derivative with respect to x, so we don't actually see what those x's are, but we still can. So for now, we're just going to treat y like it's just any other function, like ln of x or something. So it's going to be a product rule. So I'm going to start by taking the derivative of the first thing, the x squared. That'll become 2x. times the original what we had there, y, plus now the original of the first thing, x squared, times the derivative of y with respect to x. So the derivative of y with respect to x is just dy by dx. And we're just going to leave it like that, and that's perfectly fine. Now for this other one, we have another product rule here. We'll start by taking the derivative of y squared with respect to x. So for that, we can use the power rule. So it'll become 2y. But we have to remember, we took the derivative of y, and y from x is hidden inside of it. So because of that, we do need the chain rule dy by dx. And then this x stays the same. And then plus, now for product rule, the y squared stays the same. And we take the derivative of the x, which is just 1. So y squared. Oh, Ellie, you're in high school learning tensors? Oh my god. I have a degree in math and I haven't learned tensors. Okay, and so now from here, all we have to do is isolate dy by dx. So I'm going to subtract everything without the dy by dx over to the right side. Oh good, here's the leaf blower. Minus 2x. I hope my mic isn't picking up that leaf blower, but it's kind of loud. And now on the left side, I'm going to factor out dy by dx. And now all left to do is to divide each side by x squared plus 2y. And I'd say that's our answer here. Hey, Waffle, it is. Hope you're doing well. All right, so Yusuf, I'm sorry, probably took too long, you had to leave, but I hope if you do check the recording that helps you. Feel free to tune into the next stream or post in my Discord, and I'll be able to explain to you more. Okay, Jaden. I need to scroll up in chat to find Jaden's problem. I didn't copy that one down, so I was... scrambling. Oh, if you redeem that, I'll literally do a Minesweeper. But right now there's too many questions that are waiting. Oh, shoot. Joey Del Monico, you asked a question ages ago and I didn't even see it. So yeah, if you want to refund it, but it's probably going to be a little while before I can do it. Okay, here's Jack Jennings' question. Let me copy that down before I have to scroll back up in chat. Sine squared x plus sine x on 0 to pi. Okay. What did Mateo ask? I'll find it out later. Still scrolling up. Okay. Oh gosh, Jaden had the bearings problem. Yeah, sure, Waffle. I'll refund you. God, I hate these problems. Okay. Can I find Mateo's on the way back as I scroll down and chat again? Here, okay, I found Mateo's. Oh yeah, but I think Territar maybe explained. Okay, I didn't see Mateo confirming, so I'm gonna still explain Mateo's problem. Just in case. But I just need to scroll back down through chat and see what else I missed. Oh, Mateo posted a different question that they probably want help with more. Limit as x goes to 3, x over sine pi over x times x. Weird. X times x like that. We'll deal with it when the time comes, I guess. X times x. Okay. Oh, okay, Jack. It should be okay. So I'm just going to... actually, Jack, if you're here, Jaden already had to leave anyway. So maybe I'll just work on yours. Since you're here. Let me take my sweatshirt off quickly, but yeah, we'll do yours first. And then Mateo's here, we'll also do theirs. Okay. So Jack, you want the extreme values of sine x squared or sine squared x plus sine x on 0 to 2 pi. Cool. So I would take the derivative of this thing to start with, because that's just how you find extreme values. So when you take the derivative of sine squared, we start by doing the power rule of the squared, so we get 2 sine x, and then chain rule, we have to multiply by the derivative of sine, which is cosine. Now we take the derivative of sine, that just goes to cosine. So that's our derivative. And then to find extreme values, you set the derivative equal to 0. And for here to solve for x, let's factor out the cosine. Put 2 sine x plus 1 equals 0. Now we can split it up into 2 separate problems where either cosine of x equals 0 or 2 sine x plus 1 equals 0. So x is between 0 and 2 pi. So from the first equation, cosine is 0 at pi over 2 and 3 pi over 2, just from knowing the unit circle. And then the equation on the right, we get sine of x is equal to minus a half. And the unit circle, where there's a negative 1/2 is in quadrant 3 and 4. We want pi plus pi over 6 is 7 pi over 6. And we want 2 pi minus pi over 6 is 11 pi over 6. Let's fact check that. In a circle. Seven pi over 6, 11 pi over 6. Bam. Okay. I still know my unit circle. So Jack, I would say the answer to the question, they're simply asking what the extrema are. And so I'd say the extrema happen at pi over 2, 7 pi over 6, 3 pi over 2, and 11 pi over 6. If they give you like closed brackets, if they instead give you that 0 and 2 pi, you should check these endpoints to see if they're possible like extreme value. But since we don't have that, I think we can safely just say that these things down here are the answer. And so we could go on to classify these as minima or maxima, but they didn't really ask that, so yeah. Oh, and Derek, if Ellie doesn't want to say the name or be too specific, I know that you're curious, but you should just respect that, please. And I'm sorry if I'm inserting myself and Ellie is okay with it, but yeah, Ellie, please don't feel pressure to say anything you don't want to say. Okay. Thank you so much for your patience, Jax. For your patience, Jack. Let's look at Mateo's is a smaller problem, so even if Mateo's in here, let's just do that one first. Because Jaden isn't here anyway, so it's not time sensitive. So I think Mateo got their answer. Let's still answer the thing about domain. Root x squared minus 4 over x minus 3. And so I think Mateo already got their answer, but just to kind of reiterate it, Dr. Cook is divide by 0. Anders. You should be in mind. How we think about the domain of the function is I try to figure out x values that would break this. And what I mean by break is like breaking the rules of math. So we're not allowed to divide by 0. Like in this function in particular, the things we need to look out for are dividing by 0 and taking the square root of a negative. Those are two things that we don't like, or like that would make things weird, I guess. So we need to exclude anytime the denominator is 0. So we need to figure out when x minus 3 is equal to 0 and make sure to throw that out. So at x equals 3, the thing is 0. So we know x cannot equal 3 because we don't want to divide by 0. We also want x squared minus 4 to be greater than or equal to 0 because taking the square root of a negative doesn't make sense. Well, unless you want to do complex numbers, but we're not doing those. And so we can add the 4 to the other side. And then we can take the square root of each side. We have to be a little bit careful about it. It's going to be the absolute value of x is greater than or equal to 2. Because if you take the square root of something squared, it is taking the absolute value. And for inequalities, that matters. And so this means that x can either be greater than or equal to 2 or less than or equal to negative 2. And so what I'd say is that if we could think about it as like a number line, 2, 3, 4, -2, -1, 0. 1, 2, 3, 4. Okay, so the things that we're allowed to have, less than or equal to -2 is fine. Greater than or equal to 2 is fine, except x equals 3. So that's how it looks visually. And we can write that with interval notation, like we can get the arrow on the left here by saying from -infinity to -2 inclusive for the -2. Union, basically combining it with the next step, which is going to be from 2 to 3, so like this little bit here. The 2 is inclusive, the 3 is not. Union, then from 3 all the way out to infinity. And I'll say that, I don't know what country you're in, Mateo, but some countries have different notation for this. In America, we use these parentheses, but in some countries, they do like a reversed bracket. So I'm just going to say that this is a possible answer too, depending on where you live. And even then, there's other forms of saying this answer, which are, like you write this all with inequalities too, like x is less than or equal to 2, or sorry, to -2. Or 2 is less than or equal to x is less than 3, and x is not or equal to, x is greater than 3. So like this is completely equivalent using inequalities as well. So there's different, depending on the class, they want different forms of the answer. That's how you do that first one. So Mateo also, oh, I didn't type Mateo's name. Unbelievable. Okay. All right, so Mateo, if you're just seeing this part of the recording, I just worked out your problem here and just rewind a little bit more to see me explaining it. And I'm about to go into the other problem, yes, which was the limit. Limit as x goes to 3. Now this one, it didn't quite make sense to me though. Let me write down how I interpreted what you said. Limit as x goes to 3 of x over sine of pi over x times x. And that x times x bit was the weird thing to me. So the denominator, Maxi is saying, so the denominator is always parentheses while numerator is brackets in terms of limit notation for domain. I wouldn't say that, Maxi. Not necessarily. That's a good question. It kind of depends on where, so it is sort of related to like, it's not necessarily denominator numerator, it's what the function is. So like denominator, you'll always get these kind of like single values that don't work because, you know, you just can't divide by 0. You can divide by anything else you want. So you'll get, you know, one or a few values where the denominator could be 0 and you have to exclude those. And those will kind of give you some open parentheses there rather than the square brackets. So yeah, from the denominator, you do tend to get parentheses. I wouldn't take that as a rule necessarily, but or like depending on it, and I think it's open to being misinterpreted, but I think what you're going for is kind of right there with the denominator gives you the parentheses. The reason we get brackets from the numerator isn't just because it's in the numerator, it's because it's a square root function. And just the types, for the square root function, we have a range of values that don't work, which is anytime this thing is less than 0. And so we can have it be equal to 0. We are okay with it being equal to 0 or more. And that including 0 part is why we tend to get the brackets for a square root, because we are allowed to include 0. I think something that's good to consider is, say, ln of x over x. For ln, you cannot plug in 0. And so from the numerator, you would get x is greater than 0, which would also be parentheses. So you get like 0 comma infinity from that part of it. So it's not, that's what I'm saying, it's not necessarily a numerator thing, it's a what function is in the numerator thing. Because square root is different from ln, is different from reciprocal, and everything else that has discontinuities like that. Okay, trying to figure out this limit. I think we just plug 3 in directly. So I'm worried that I'm misinterpreting the denominator here. But if I'm not, we'll get 3 over sine of pi over 9. There's nothing wrong with just plugging 3 in directly here, but sine of pi over 9 isn't unit circle. We can split them sine of pi over 6 plus pi. No, we can't. Pi over 3 minus pi over 6 is pi over 9? Is that it? No. Pi over 3. Let me scroll back up and check. So, Mateo, you said you got like -3 for an answer. Okay, yeah. You're saying you got -3. Oh, wait. If you did get -3, then maybe I did misinterpret your question here. So maybe you actually had that. No, no. I don't think you did. I don't know. Let's just see if we can figure out what sine of pi over 9 is. I feel like I'm misinterpreting your question, though, and we're not going to get -3 out of this. So you could call this the answer, and actually I'm just going to plug it into Wolfram Alpha because I'm curious if what this is. 3 over sine pi over 9. Oh, triple angle, Zach, yeah. Okay, yeah, that's definitely not -3. So I'm definitely worried that I'm misinterpreting the question here. Hey, oh gosh, I don't know how to pronounce that. Nawang? I'm sorry if I'm butchering that. I think my idea, what idea did I have? No, I don't have an idea. I want to use a sum or difference. Oh, I got it right? At least more or less? Thank you. Either way, it's definitely someone the person did. So I'm just... There's a way to evaluate sine of pi over 9, I think. There's a thing called the triple angle identity you could use, but I feel like I'm misinterpreting the question here, because it's a weird way, like the x times x thing is what's giving me pause here. So, Mateo, if you are able to back me at some point and maybe clarify for me, I would appreciate it, because I'm not seeing... what to do here. Or I feel like this is wrong, so I'm just going to leave it there. Nawang, we're just looking at a limit problem from Mateo who popped in chat earlier. Sorry, I have a whole queue of people I was trying to keep track of here. I was trying to figure out the sum of angles teratar, but I couldn't find the combination to get pi over 9. That's unit circle. So we were just talking about a limit problem from Mateo. So the theme of the stream in general is I take math questions from chat and I try to answer them as best I can. A lot of times people ask questions that are just way beyond me. Today's a bit of a busy day, so I started keeping a queue. And I finally nearly cleared it, except for this bearings problem. I did the domain question, yeah. Or Mateo asked too. The second one that they asked was the limit one, but I also did the domain one. Mateo asked too, so I did them both. But I think I don't think I'm interpreting the limit one right, so I'm just moving on. But yeah, the theme of the stream is I try to answer questions from people in chat. It's been a busy day today, but the last one that I have to answer that I know of for now is this word problem here from Jaden. I mean, it's just a weird problem. It's not necessarily hard, but it's the limit as x approaches 3 of x over sine of pi over x times x is how they phrased it. And that's why I'm weirded out, because why is it x times x in the denominator? They said they got -3. So I made it x squared. That's how I'm interpreting it. But I don't know why they didn't say x squared. And that's making me wonder if there's something weird with the problem. So you could just plug 3 in direct and get 3 over sine of pi over 9, but I don't think that's what they were like. I feel like the x is actually somewhere else or something like that. I think there's something that I'm not getting here, so that's why I'm moving on. Delete that. That feels good. And let's start thinking about this Lighthouse problem. But then, like, that I was thinking that too, but then it would cancel the x in the numerator, and that's also weird. So, yeah. Yeah. That's why I'm just kind of throwing my hands up there. Hey, Mo Games, probably saying that wrong. The quick answer to that is that you'll take the derivative of it and set it equal to 0, but I want to work on this problem first, and then I can work on yours after. I'll copy it down here. Yeah, I majored in applied math. So I'll get to yours after this, and if you have to leave, Mo Games, I'll type your name in chat when I get to it, and you can look at the recording after. And yeah, it might be that someone in chat will take up that question too. Screen math for comp majors who hate math. A lighthouse located at point L and two ships A and B are moving in the ocean. The angle of the relation from ship A to the top of the lighthouse is, oh god, 25 degrees and 25, I assume that's like arc seconds or whatever. That looks separable, Snipes. I can do it, but there's a new queue that's forming now. Let me write down your problem too. Oh, that's a double prime. It's still separable though. Or I think you can still just separate it and integrate it twice. But you're right now number 3 in queue basically. So I'm working on this word problem and then one for Mo Games and then it'll be you. You're picking analysis class. It's sort of funny. We know stuff and go to. Oh yeah, Ellie. Both ships are in a straight line at the lighthouse. Distance between the two ships is 550 meters. Ugh, the high lighthouse is 100 of each ship from the lighthouse using. Okay, this might not be the worst thing. 3, Anders. Including this problem. Do you want me to add you? All right. This first one is 25 degrees in 25. Is that arc seconds? I forget. I'm probably doing the wrong symbol, but and that one is 15 degrees, 15 seconds? I don't remember. Dude, degrees are weird. That's L. The lighthouse is 100 meters. So that side is 100 meters. The distance between this one is A, this one is B. The distance between the ships is 500. Differential equations can only be described as the language of the universe. Ooh, I like that, Territar. Actually, doing this stuff has ruined that for me. I don't like numbers. If you do this without numbers, you'd be in love? Interesting. I did not like physics until I learned multivariable calculus. And that being able to use multivariable calculus with physics made me really like it. I didn't like it until then. Oh, okay, Anders. I saw you posted something out. I'll take a look at it. Worst case, after the stream, like sometime tonight. We want to find this distance here. So I'd say that, let's call it D, just so we have something to work with. This is just, okay, this actually isn't so bad. So we can use some trig here, because we know that tangent is opposite over hypotenuse. So tangent of 25 degrees, 25, I think seconds, is opposite 100 over D. So then multiply each side by D and divide by the tangent to get D is 100 over tangent. And that's work for a calculator. Okay, I'm glad this one, these bearing problems can be, or these problems like this can be really brutal. So I'm glad this one isn't as bad as I thought. Ooh, I don't know how to put this into Wolfram Alpha though. 25 degrees. Ooh. What even is that second thing called? Is it seconds? Seconds of arc for seconds. I think that's right. Yeah, arc seconds. 214.4, that's probably reasonable. Um, calc-based physics. My calculus-based physics did not have multivariable calculus, and I hated it. Degrees. Oh, it's minutes? Okay. Thank you, Fembox. I'll have to update the Wolfram Alpha. We love quantum mechanics, so there was seldom see any numbers there. Oh, wow. So yeah, I mean like multivariable calculus. Pattern solving math, you have proving 2 is such an uphill climb. Yeah, that's true, Snipes. Yeah, Ellie, that is a tough sell. Does multivariable include 2D? Yeah. It's like I mean it'll also answer for 2D, but they normally ask you about like 3D. Arc minutes. Okay, 210. Wow, that's a small difference. 210.4. Eraser? Oh, it is. Okay, there we go. But yeah, like the thing about like multivariable calculus is that it also answers the single variable questions too. Snipes. Oh, yeah, no. So like as part of my degree, I only ever did calculus, or I did multivariable calculus, and I never did physics with multivariable calculus, and it was lame. And I graduated like 5 years ago or 6 years ago or something. And then just like recently, I've been studying it with multivariable calculus, and it's been a ton of fun. Oh, wait. Okay, from the base of the lighthouse. Is just 210.4 meters. Distance from B to the lighthouse is the same thing, but plus 500. So that's 710.4. Does that make sense? Theoretically, we should be able to do 100 over... Oh, no, that'd be D plus 500. It probably makes sense. Yeah, the physics class that I took tried to take the 3 dimensions out of it, and I hated it. Like, there were still 3 dimensions in it, but they didn't use any actual, like, line integrals or surface integrals or anything like that. Or gradients. And they just make it way more interesting. And yeah, Calc 3 is multivariable calculus normally. My Calc 3 class never did divergence. Didn't do Stokes. I think it ended with greens, to be honest. It didn't go into vectors that much, which is kind of a shame. It did some. AP Physics 1 in analysis, sort of fake, then AP Bio plus multivariable. Wow. That's a full load, Ellie. So it sounds like your teachers are like really laying it on you too, so best of luck. Determine how far the ships are from the lighthouse. I think we've answered the first part of the question from the base lighthouse. I assume for the second part they want, rather than from the base down there, they want the distance from each ship to the point L up here, which we can do with I guess sine or cosine will work here. Analysis for the first time you've seen calc stuff. Oh, okay, yeah. I didn't know that they did classes like that for high schoolers. I definitely could see that being really weird. They call analysis, but it's not really. That sucks. Wait, don't I have this backwards? Shouldn't... No, I don't. The narrower angle should be on the right. Yeah, that makes sense. Okay. So we know that sine of 25 degrees in 25 minutes is opposite over hypotenuse. So 100 over the distance from A to L. So we can, again, just rearrange this and say 100 over sine of that angle. And plug it into a calculator. $233. Okay, yeah, that does make sense. Excuse me. 233 meters. And then the other one will just change the angle. So 15 degrees, 15 arc minutes. 380.2. Is equal to 100 over BL. So BL is 100 over sine 15 degrees, 15 minutes. What did I say that was? 380.2. I forgot to get the decimal for the other one, but it doesn't matter. Okay. So yeah, I think that's the answer to the question, Jaden. I hope that helps. I need to move on to Mo Games next. Get rid of that. Get rid of all this. Okay, so Mo Games is asking this. Let me type their name in chat. And then Snipes will be up next. So Mo Games had that cubic function, and we have to find where the tangent is horizontal. The tangent being horizontal means that the derivative equals 0, because 0 slope is horizontal, and the derivative is the slope of the tangent. So let's start by finding f prime of x. We're going to use the power rule here. X cubed goes to 3x squared, 4x goes to 4, and 1 goes to 0. So let's take 3x squared plus 4 set equal to 0. 3x squared equals -4. X squared equals -4 over 3. So we don't actually get any solutions for x where this happens. Because unless you want to allow imaginary numbers, which we typically don't, there are no solutions for x where this thing equals 0. So this cubic must look something like that, and that's perfectly fine. Well, yeah, because that never has a horizontal tangent. So the answer to the first one is none. I hate applied math, but I love econ. Okay, and so then for their next question, we had to look at f of x equals x times 2 to the x. What is the equation to line tangent to the graphs of both 1 over x and x squared? Cytos, I'm gonna have to put you in Q. I'm working on this question. This one that I'm working on right now should be pretty short. Then I have one from Snipes that shouldn't be too long either. And then it'll be you. Tangent to both. I don't know exactly how I do it offhand. The slope should be the same, so maybe we'll equate the derivatives. Yeah, I'll type your name in chat too, in case you step away or something. Thanks for the patience. So f prime x, we have to do a product rule here. So I'm going to start by taking the derivative of the x, and that goes to 1, multiplied by the original of the other one, 2 to the x. Now plus, leave this x alone, multiply it by 2 to the, and then 2 to the x, the derivative of that is 2 to the x again, times ln of the base, which is 2. I'm earning my money tonight? I guess so, depending on... I mean, the YouTube chat, I can't even... I don't get paid anything for the YouTube. I need more watch hours before they will do that, but I don't know. It's at least busy, and that's good. So what I'm going to do here is I'm going to factor 2 to the x out of here. And then we get two separate problems. 2 to the x equals 0, and 1 plus x ln 2 equals 0. There's also some from Twitch, I guess, so that's fair. On the left, we don't get any solutions for x. Exponentials are never equal to 0. None. Over here, we can definitely isolate x and get x equals minus 1 over ln 2. And so I'd say this is the only solution that we get for that one. So I don't see typing in chat Mo Games, but if you do check the VOD later, I hope that helps. The hardest math class is always going to be whatever you find the least fun. That's kind of, yeah. That's the real answer there. All right, now Snipes is up with this. Oh, really? Differential equation here. Okay, so you have y cubed y double prime plus 1 equals 0. Real analysis is very theory. Yeah, so you probably like that. What I would do here is, this looks separable to me because there's no x's at all. So I'm going to subtract the 1 over to the other side. And I think we just integrate this baby twice to get y. Oh wait, Territar, you're saying a different strategy. Is there a problem just integrating this? Oh, hey, Mo Games. Yeah, if you have... Sorry I moved on so quick, but if you have any questions, do let me know. Oh wait, so Territar, you're saying to say that y double prime equals minus 1 over y cubed. Multiply each side by y prime. And then integrate? Oh. Yeah, because I'm kind of curious, like I was... I thought this would integrate cleanly. Does it not? The integral of y double prime y prime is 1 over 2 y prime squared. Really? This is a trickier problem than I thought it would be. So Territar is saying the integral on the left is apparently 1 over 2 y prime squared. How are you even judging difficulty in the first place? That's always the trick. Yeah, so I want to derive that thing back to actually, like, I don't see that at all. I believe it because, you know, Territar is Seems to be pretty dang good at math, but how the heck do you take the derivative of this thing? We do the power rule first, I guess. Okay, -1 over y prime, and then... Oh, wait, no, is that the -3? Y double prime? Oh, okay, that makes so much more sense, Territar. I was like, okay, okay. With respect to x? Oh, okay. Thank you, Territar. And so this should be d by dx here. That makes more sense for what I'm doing. I'm just kind of... Okay. Oh, okay. I see that now. Okay, that makes sense. Okay. Wow, that's a tricky thing to spot if you haven't seen it before. So the integral of y prime y double prime is 1/2 y prime squared. That's kind of crazy. Yeah, the reduction of order idea seems like it theoretically should work. But this way from Territory I definitely want to investigate too. Same reason in physics that integrating f equals ma yields 1/2 mv squared. What's this integral on the right then? Oh, it's a u sub, I guess, right? U equals... Is that? U equals y. So du is y prime dx. It should be y prime squared, I think, Dirk. I don't think I've ever done a u sub like this, but I think this is valid. Oh, that becomes +2. AM 255 squared minus 245 squared in less than 10 seconds? I wouldn't. I would fail. Oh, you factor as a difference of two squares. Yeah. Yeah, y is a function of x, Snipes. That's... I mean, yeah, that's usually a safe assumption with these. Okay, so then what do we get? 1 over y squared plus c1. This is kind of a crazy problem. I wonder if taking v equals y prime... I don't think that would work, actually. Because then what does the y? Huh. Okay, so... Part of your 30-minute quiz with 3 other problems? Oh my god! That's an insane quiz. So do we want to take the square root here? Like, or can we integrate y prime squared directly? Separation of variables? Okay, that... Probably just by taking... Can we divide? I think we can just make that C1. Yeah, I kind of like finding C1 right now. Wait, but what is... Oh wait, y of 1 is 2? If we use the initial condition now? I guess we want the positive root. I don't know, man. No, it has to be the negative root. Because otherwise this doesn't work, right? So then is y prime the negative root 4 over y squared minus 3/4? That's terrible to integrate, though. They're integrating... Oh, Luber, you're... After integrating, the 1 over u cubed should be 2 in front instead of 1/2. Isn't that what I have? Oh wait, on the left side. No? The 2 in front? No, on here. Oh, you're right, yeah, you're right. Oh my god. I have to divide by the new exponent. And y of 1 is 2. So it becomes 1 over 8. So we get 1/8. This is still terrible to integrate, though. I want to see what Wolfram says the answer is. Because I'm... Maybe... I don't even know. I don't know how to interpret that to see if we're on the right track or not, to be honest. Y prime of 1 is equal to minus 1/2 squared. Right, yeah. Screw 1 over 2 squared plus c. Can't tell if you liked it Diff Eq or not. I really enjoyed it, but it probably be a little bit too numbery for you. If that's what you don't like it, Ellie. My Diff Eq was not at all theoretical. Oh, yeah, we can cancel the 1/2. Good point. Just get rid of all this garbage. Okay, so C1 is 0 then. And that matches what you're getting, Derek. Well, I think it has to be the negative square root because you get it, like, the initial condition is just, like, it has to be a negative. Okay, so that makes things a lot simpler, right? Because now we just have y prime squared equals 1 over y squared. And if we know we need to take the negative root, we can say it's equal to minus 1 over y. So then y prime equals negative 1? Theoretically? Like that? Okay, yeah. So then that becomes 1/2 y squared is equal to negative x plus a new constant c2. Can you please integrate x to the x? I don't know how that integral works. I know how to take the derivative. Okay, then we know y of 1 equals 2. Two squared equals negative 1 plus c2. Three equals c2. So our answer is y equals 2 root 3 minus x. Yeah, sorry, Amy, you're out of luck there. I'm not trying that. Does that satisfy the original thing? Well, there's only one way to find out what's right. Oh wait, the 2 should be inside the square root. I did mess that up. So y prime is 1 over 2, 6 minus 2x. Oh, the second derivative is going to be painful, isn't it? No, maybe not that painful. I don't know if you're still here, Snipes, but I will absolutely like back up and explain this better. I'm just trying to figure out what the hell is going on with this problem. I need to change the exponent. If this checks out, though, that'll be pretty amazing. If I go die any further, I will die too many numbers. You sound like the perfect analyst if you're allergic to too many numbers. It's not. Oh my god. There. 3/2. Okay. So then y cubed 6 minus 2x cubed times y double prime 6 minus 2x to the minus 3/2 plus 1 equals 0. Yes, Snipes. Oh no. We need a negative sign here. Oh wait, we have a triple negative. There we go. This is the second derivative is negative. That thing is -1 plus 1 equals 0. Oh my god, it's a solution. It's a Christmas miracle. Okay, so Snipes. This is not... This problem is more than meets the eye. It's like a transformer. So what we did, to summarize, we started by subtracting the 1 to the other side, and Tartar, the Chad, figures out that you can multiply each side by y prime, because that gives you a clean integral on each side. The integral on the left is easier to do backwards. You have to figure out that y prime squared times 1/2. If you derive it, you get this, which is just a really difficult thing to spot. The integral on the right is a u sub. So y is a function of x here, so the u sub is a little bit weird, but we take u equals y, and because y is a function of x, and we're taking the derivative with respect to x, it's like implicit differentiation. So it's du equals y prime dx. So the y prime and this u sub cancels with the y prime and the integral, and we just get the integral of 1 over u cubed du, and that we can do directly. So now we're down here. We can just get rid of the 1/2, so we don't have to care about C1 because it's just a constant. It'll be whatever it has to be anyway. And then to make the next task a little bit simpler, we just applied this initial condition early with y prime because we can. And so I took the negative square root because y prime of 1 is -1/2. So I set -1/2 equal to negative root 1 over y squared plus c1, and I found that c1 is 0. So we can write that y prime squared is equal to 1 over y squared because that first constant turned out to be 0. Can I ask your Russian professor the easier way to do it? If there's an easier way, I'd love to hear it. And then this problem is now just a separation of variables, more typical Diff Eq. Take the negative root of both sides for the same reason. Multiply the y over, and then you integrate. If you get to come back, yeah, please do. But unless there's any question for you, I'm going to move on. Because Cytos asked a question before. And I am going to need to wrap things up at some point here, guys. So, but potentially, Cytos will be the last question here. Well, Anders didn't want me to look at the thing he posted for one of these. I might do that. I need to figure out what the exponent was here. I was a little bit lazy. Is that x squared? At Cytos. Scrolling up in chat. Yeah, it's x squared. What is the equation of line tangent to the graphs of both 1 over x and x squared? Oh, cool, and you're still here, Cytos. Thank you for confirming that it's x squared. Okay, like, intuitively, where do we expect this thing to be? Pretty good on not deriving tonight, 4 out of 5. I'll take it, $10. Okay, I could see there potentially, maybe not. No, I don't think there'll be a tangent like this. I don't think that'll be possible. I think our only hope of a tangent is maybe like that. I don't see anywhere else where we can have the same tangent line. So just trying to get intuitive feel for what to expect for a tangent. And I think a negative x seems reasonable. So I'm going to name 1 over x as f of x and x squared as g of x. No, that's not important, but f prime is minus 1 over x squared. G prime is 2x. Now, my idea was to set these things equal to each other because the slope of the tangent line should be the same if it's the same line. So what do we get here? Multiply through by x squared. Well, that seems reasonable. We're getting a negative answer. 1 over the cube root of 2? Ah. Super cool doing math homework right now, but I know the concepts. Oh, nice, Yoshi. I appreciate the kind words. Good luck with your math homework. Did I do something wrong? Wait. -1. Oh, I'm trying to plug it back into f prime and g prime to verify this answer. It's good. No, is it good? 1 over 2 to the 2/3, right? It's equal to -2 to the 2/3. What do we get for g? 2 times 1 minus 1 over 2 to the 1/3. Oh, no, okay, that's fine. For whatever reason, I just didn't feel like they matched. Okay, so we do want the actual slope of this line. Because we found the x value, but the actual slope of the line is the y value. So we can plug it into either. G prime looks easier. I should have just kept, it was -2 to the 2/3. Hey, Lucas. Informatical question for you. Why does my screen get moisture when I go all under my blanket, but not when I just sit normally? Oh, like your phone? I don't know. Probably because like the condensation where you're breathing or something. The way you set up the equation implies the x values are the same at both tangent points. I guess you're right, Cytos. Is that cool, Lucas? I don't. Okay, yeah, I see the problem you're pointing out there, Cytos. They don't occur at the same x value, do they? Y equals 0? I don't think so. I'm thinking there should be... It seems like there could be a tangent line like that if you actually draw it straight. Hey, Jed. I feel like it's possible to get one that fits in with like the left side there. How do we do that though? Well, yeah, but infinity isn't a number though. Like theoretically, yeah, Jed. But like infinity never actually happens. This is like math, and then they get mad at me when I tell them to put a Kolomai-Yau manifold all over their world and solve my small issue with solving a few tiny equations. Ugh. Yeah. Yeah, Jed. That's what I didn't like about it. All right, well, I guess we know that. Can we say that y equals -1 over x squared as our slope times x plus b? And also that y equals 2x, the other slope, times x plus b? That doesn't really make sense, though. I came over to Twitch, too. Thank you. So do you know the answer to this question, then, Cytos? Because I think I'm out of ideas. Yeah, let's say I don't know what that manifold is, but it sounds smart. You made the problem. Okay. Oh, that time I muted in time. Is it just -x? That'd be annoying if it is. No, it'd have to be shifted at the very least. Consider all possible tangents to x squared. How many of them intersect 1 over x? I think they all do. Somewhere. Like, that one's going to intersect. That one's going to intersect. Not all of them, yeah, you're right. Maybe that's the key? I remember in some similar feeling problems, we do like 1 over x squared is equal to rise over run. Lubert is saying 4x minus, or minus 4x minus 4. And that's the right one? Wow. Oh yeah, Jaden. If you want, scroll. Okay, nice. No worries. Thank you for the question. You can label the points of intersection along tangent and call them A and B. So, like for -1 over x squared, we could say it's equal to like y minus a sub x over x minus, oops, a sub y. I don't know that's what we're supposed to do. A f of a. Oh, okay, that's probably, yeah. I guess I'll put A up here because it's first. Heard about string theory. Now make jokes about it. Seem funny when I'm too real. So like, can we say that -1 over x squared is equal to f of b? I want to equal it to rise over run. I mean, can we call it, can we do f of b minus f of a? No, that just gets me back to where I started. Or I guess that b, or g. Hey, Yijing, well, welcome in. How good is my Calc 3? I'm struggling with triple integrals. I'm decent with triple integrals. I'm kind of rusty. Question about trinomials. Do we have to see if we can GCF it before doing everything? Ooh, for greatest common factor for a trinomial? I don't know what that means, Sieging. Thank you for following, Cytos. Like, why would the greatest common factor help for factoring it? Yeah, 997. We're getting there. All right, see you, Derek. Thank you for hanging out. Oh, are you saying like for factoring something like this, Yijing? Like x squared plus 2x plus 1? I can set up two equations A and B with the current information, Cytos says. I can? Slide and divide method of factoring. Oh, I looked at that once. It's not the type that I normally use. Yijing, I can try and look at it after this. I'm trying to figure out Cytos's problem, but like, is it y minus f of a equals, I guess, prime a x minus a, and we know what f and f prime are. And the key is, if we do the same thing with g, like these x's and these, this is the same y and x. Oh, and then, oh, do we equate coefficients then? Hey, Sean. Okay. Maybe I see kind of what to do here. Ah. Do you do? Yeah, I love Calc 1. Two over A? Yeah. Y equals 2bx minus b squared. And if we equate coefficients, we know that 1 over a squared equals 2b, and that 2 over a equals minus b squared. So then 1 over 2a squared equals b. 2 over a equals minus, 1 over 4a to the fourth. Yeah, sure, Sean. I think we might need to talk to Yijing first about factoring, and then it'll be you. To make sure I'm not missing anything in my Discord. I don't think I am. Okay, what happens here? If we multiply 3 by a to the fourth, a is minus a half. So b is 2? I'm plugging into this equation here. I dropped a negative. That sounds like me. I see where I dropped the negative right there. All right, Ellie. Thanks so much for hanging out. Enjoy your dinner. Okay, yeah, it got squared anyway in the sub on the right. So I think that work is still okay, but then this will become -2. That makes more sense anyway, I think. Well, these two things should give us the same line, right? If we plug a and b in. Y is minus 4x minus 4. That's what Luberg got if I plug in a. If I plug in b, minus 4x minus 4. Wow, okay. That's a neat problem, Cytos. Okay, so Yijing, are you still here? If not, I'm just gonna move on to Sean's question. Actually, Sean, if you want, feel free to just like post your question too, and I'll like get to it once I can. It's because Yijing may have left. So He may just be up next anyway. Yeah, I've seen this before. It's not the way that I learned, so I'm not used to it. We'll probably wrap up with Sean unless someone pops in with a burning question or something. Oh, wow. I don't need this one. I got completely derailed from that talk, but... Okay, yeah. I remember that being the idea. The limit as x goes to infinity of root... should this be as u goes to infinity? No worries. So yeah, L'Hopital should work here, but I'll even give you a different trick, because whenever there's a function like this, there's intuition that you can use by looking at the degree on top and bottom. So on top we have a u squared, but square rooted. So we could think of it as like degree 1. Oh god. And on the bottom, we just have the degree 1. And when the degree on top and bottom are equal, you can take the leading coefficient on the top divided by the leading coefficient on the bottom. So I expect us to get 1 here for this limit. And if the degree on top is more, you get infinity. If the degree on bottom is more, you get 0. But we can show that with L'Hopitals. There's actually, we don't even necessarily need to use L'Hopitals for this either, but since you mentioned that, let's show how that works, because you should know how to use L'Hopitals for a limit like this. It's good to know. So if you do L'Hopitals for this, we take the derivative of the top, which is 1 over 2 root u squared plus 1, then chain rule times 2u. The bottom u just derives to 1. So we get the limit as u goes to... Oh, does it not work? Yeah, okay, I might see what you mean now. I thought L'Hopital should work for a limit like this. If we did... Oh no, I'm not showing my screen. Dang it. I'm sorry about that. Rookie mistake. Yeah, if we do L'Hopitals again, that's funny. I guess L'Hopitals doesn't help. All right, I thought it would. Actually. So what you can do instead here, it is rough and I've seen this trick phrased in many different ways. How should I actually let me not phrase it in this way. There's many different ways this trick is shown, but what you can do with functions like these is factor out the highest power of u that you possibly can. So from the inside, we have a u squared, so let's take that. And then the bottom, we just have a u, so we can't really factor much out from there. Oh no, I made that mistake. as u goes to infinity. Now this u squared can come outside the square root as long as it gets square rooted along the way. So we get u times root 1 plus u squared over u. And now the nice thing about this trick is that we get a cancellation with the u's. So this thing is equal to the limit as u goes to infinity of root 1 plus 1 over u squared. And this limit we actually can do because this term here goes to 0 as u goes to infinity. So we get just root 1, and that's 1. So I think it's kind of weird. I thought the L'Hopital's works, but I guess it doesn't. No, Teratar, I'm not speaking properly when I say derive. I just don't care that much. It is differentiate. If you derive an equation, it means you prove an equation, and it's just that the derivative sounds like you should be able to derive it, but it's not right. I just don't care enough to correct it every time. No worries, Sean. Thank you for the question. Winston. And so you Femboxman in the Twitch chat likes to pick on me for saying derive instead of differentiate, because it isn't right, but all right, so maybe Winston just put a question here, and I'm kind of curious to see what the answer is. So let's see if we can work it out. Winston says, find the area of the largest isosceles triangle having perimeter of 18. So the other one we'll name L. So perimeter is equal to 2x plus L is equal to 18. The area of an isosceles triangle, we need to figure out the base is L, but the height is, I feel like I should know this. All right, see you, Sean. Slogo, I have a bachelor's in applied math, and I've worked in a tutoring center at a community college. And I've also done a good bit of private tutoring just for like friends and family. Oh, duh, Pythagorean theorem. The height is L squared over 4 plus x squared, right? Because if we look at just... No. If we look at just 1/2 of this isosceles triangle, that's L over 2 on the base. Pythagorean theorem gives us x squared minus L squared over 2. Okay. A Lagrange multipliers? I think this is a single variable problem. This feels like a Calc 1 question. So the area of a triangle is 1/2 times base times height. The base is L. The height we just worked out as root x squared minus L squared over 4. I made a typo. Oh, is it? Maybe there is an issue here, Tiratar. I guess I'll run into it if there is one. But I think I want to sub out for X or L in the next step using the perimeter. Oh, I'm about to transfer from a community college if I finish Diff Eq and discrete next semester. Tutors are a big help. Oh, awesome, Logo. Good luck with the transfer. So we know from the first equation for perimeter that L is equal to 18 minus 2x. So we can plug it into the formula we got for area, and we now have, what am I doing? I think I want to sub for x, actually. One less thing. X is equal to 9 minus L over 2. So L over 2 root. Now x we're saying is 9 minus L over 2. Squared minus L squared over 4. Okay. And that is A. Let's try and clean this up a little bit, but what I'm going to want to do is take the derivative of this thing and then set it equal to 0, because that's how you optimize it. Shout out for community college math tutors, exactly. So we've multiply out the inside, we get 81 minus 9L plus 1/4 L squared minus 1/4 L squared. That's convenient. L over 2. Oh, what? That is a freak of a 2. Okay, that's getting erased. Okay, so we get the area of this thing is L over 2 times root 81 minus 9L. And then we can take the derivative of this thing. It's going to be a product rule, but that's okay. Take the derivative of the first part. L over 2 becomes 1/2. The second part stays the same. Now we do plus. The first part stays the same, L over 2. Hey, punching. And then take the derivative of the second part. 1 over 2 root 81 minus 9L, then chain rule times -9. Ugh, and we're going to set equal to 0 because we're trying to find the maximum area, and so the maximum happens when the derivative is 0. Or minimum, but it should be a maximum if we set things up right. All right, so let's just rewrite this and clean things up a little bit. Because this looks a little bit annoying to find where it's equal to 0. Minus 9L over 4 root 81 minus 9L. I think we need a common denominator here. So I'm going to take that. God, I'm hungry. I'm going to take the first fraction and get a common denominator multiplying by 2 root 81 minus 9L over 2 root 81 minus 9L. So what we get is 2 times 81 minus 9L, because square root times square root goes away, minus 9L over 4 root 81 minus 9L. All right, that's not so bad now. Because now the denominator will never give us 0. We only have to worry about the numerator. So we can just look at this part of the equation here. 2 times 81 is 162 minus 18L minus 9L equals 0. 162 minus 27L is 0. Probably burned off a pound just doing math. I think so, Fembox. This is the ultimate weight loss strategy. 162 over 27. Does that go in evenly? That'd be a miracle. If 27 does go into 162, it would have to be multiplied by 6, right? What's 27 times 6? 2, 4, 12, 162. Wow. 6. Hey, Luminous, or Ari. I'm going to wrap things up really soon here. If you have a relatively short question, I can look at it, but I've been streaming for 5 hours and I'm getting hungry. Okay, so Winston, we found that L, or whatever the other side of the isosceles triangle is, the odd one out, is 6. And if I lost you at any point, please do let me know. My brain's slowly getting fried here, so I'm not explaining myself as well as I could. Now to find the length of the sides that are equal, we can say x equal to 9 minus L over 2. X is equal to 9 minus L, which is 6 over 2. So that is 6. It's an equilateral triangle. Oh, that makes sense. Wow. Okay. So all side lengths are 6. That makes sense. Usually equal sides optimizes the area, unless there's something fucky happening where like one side is worth more than others if you have a price. Thank you, Hobos. It was definitely it's definitely been a fun day so far. Yeah, I'm sorry about that, Ari. If you want, I have a Discord. You can post it there, and I'll get back to you either next time I stream or off stream. But I stream on Tuesdays, Thursdays, and Saturdays. So, Muhammad, you're asking about the limit of sine of 1 over x as x goes to 0. That's a little bit too big of a question for me to answer right now. I want to wrap things up. The answer is the limit does not exist, but actually proving that is a pretty difficult problem, and I don't know it offhand either, so I'd have to like Google in that. That's a little bit too much that I can do right now. Winston, I hope that helps you. I'm going to wrap things up here in like a minute. So once I see you type a question, I'm going to assume that you're okay with it. Yeah, I'm sorry about that, Mohammed. Problem answer is 9 root 3. Aw, really? I messed up somewhere, I guess. Can I spot it? That's weird to me. It should be an equilateral triangle, I feel like. That's normally the answer to a problem like this. Okay, you agree, Fembox? Yeah, Winston, I feel like I feel like this is okay. It should be an equilateral triangle. Um, so wait, what is 9 root 3 supposed to be? Is that the area of your... Oh, the area. I didn't actually answer the question. I said, oh, you know what? We might still agree with each other because I found the lengths of the sides. I didn't find the actual area of this triangle though. So let's do that. This bottom side is 3, that's 6. That is 36 minus 9 is 5. 3, 5, 6? Is that a triple? That doesn't feel like a triple. Maybe it is. No, 36 minus 9 is 27. That's the issue. Yeah. And that's 3 root 3. Okay. So Winston, I think... Oh, we don't... Wait, the area of this thing is 1/2. The base is 6. The height is 3 root 3. Oh, good. And that is 9 root 3. Okay, so Winston, we do agree with each other. So it's an equilateral triangle, and I thought that was the question, but I was mistaken. The question was, what is the area of that equilateral triangle? and the area of that is 9 root 3. Thank you for pointing that out. So let me do the question, or if you like have a question later, like feel free to just put it in my Discord too. But I do want to wrap things up here. So if if you do have a question, please like let me know quick. Hey Dinkify, I can, yes, but not today. I'm gonna wrap things up right now. If you saw the link to my Discord though, you can put it in there and I'll get back to you either next time I stream or potentially before then. But we'll welcome in though. Sorry, that's just like a bad time, but I'm going for 5 hours and 20 minutes. I don't want to eat some food. Whipping cream, can you help me with PDE? I don't know PDEs. You might be able to try and simplex Pachinko. I don't know how good he is with PDEs. He's definitely good with ordinary differential equations. I don't know them myself though. Okay, not saying else from Winston. I think I'm gonna wrap it up. Lakshya, a coin is tossed infinite times. What are the probability of getting the third head in the 5th toss? That sounds like a binomial, or maybe like a geometric probability. But I'm sorry, Lakshya. I need to wrap up the stream. All right, punching. I'll have to look at it another time, but I'm sorry, Lakshya. If you want, you can put it in my Discord, but people like at some point I gotta cut it off here so I can go and get food and all that, and take a break. So put in my Discord or catch me the next time that I'm live, and I'll be able to help you out. What times I usually stream? So I dual stream on Twitch and YouTube. The times I stream math, or basically for the sake of YouTube, me streaming math, I do that Tuesdays, Thursdays, and Saturdays at 1 Pacific time, which is basically 5 hours and 20 minutes ago, whatever that is in your time zone. But be warned, on Saturdays, I do this physics study group for the first 2 hours of the stream. I'm not open for math help then. Mox is saying for Lakshya's probability of exactly 2 heads in the first 4 tosses times 1/2. Oh yeah, that's how you would do it. OD, I know OD is decently well, yeah. Thank you, Slogo. Never just do math forever. It's conspiracy. That's what it feels like every time I'm saying I'm gonna wrap it up. Someone pops in and asks a question. It's a good problem to have though. So yeah, I'm gonna cut the YouTube show off here, and then on Twitch I'm gonna look for someone to raid. So everyone who's here on YouTube, thank you very much for being here. Welcome into all the new faces. I'll be back on Thursday. And see y'all.